Hello everyone, how's everyone doing today? Okay, this is the fifth live stream on the Dart language, and I think today we're gonna be actually finishing the boring documentation reading. So yeah, after that we'll be able to actually start working on some kind of project. So today's plan is to finish the documentation on classes. I don't know if we're gonna be skipping anything, hopefully not. We're gonna try some things out, and then I want to go through the concurrency. So see how fast we'll be able to get through that. And in the morning, we're actually gonna start setting up a project for the uh, habit tracker. Yeah, the habit tracker that we started building in React. So we're gonna do the backend in Dart just to try it out what it feels like in practice. So let's just continue. Okay, so the last time we finished with constructors, right? There was just so much about constructors. So we'll simply continue with methods. So class and object methods. Let's see what this is about. All right, so methods are functions that provide behavior for an object. Okay, so that's like the classic thing. Functions are the functions that are defined outside of objects. You just call them by their name. While methods are supposed to be the functions attached to an object. So you first do instance of an object, dot, and the name of the function is in this case method. Something very similar to C#. It's the same naming convention. Okay, so first of all, we have instance methods. Instance methods on objects can access instance variables and this, as in this element. The distance2 method in the following example is an example of an instance method. So I will already kind of point it out, even though I think it's obvious. Instance method is a method that can be called only on an existing instance. You can't just go class name dot and the name of the method. You actually need to create first. First, you need to create the point, and then you can actually call the thing on the point. Alrighty. So, yep. So let's see the example. We import Dart math. We create a point again with x and y. To move the lamp, it's just too bright in my face. Ay. Okay. So that's that. And then we have our constructor. And then we have our function. Okay, so we don't have any keywords. It's just as if we were defining any kind of functions, but within those brackets that belong to the point. So it's not like, for example, nim language where you would define or Go, where you would define those functions outside. You need to define them inside, just like you would do in Java, probably Kotlin, C#, that sort of thing. Or JavaScript, yeah. So in this case, we define distance2, which takes another point. See, it's other and double. And why is it other and not just point? Because this is going to be called on an existing point. Therefore, to the existing point, just refer as this, or like you could go this.x, this.y. But in this case, you don't even need to call this because it's obvious to the compiler that, oh, you're taking this x and you're taking this y. Right, so, okay. It takes distance x, distance y, and square roots it with your standard formula. Nothing crazy. All right. So then we have operators. Oh, so okay, so this is all the documentation we have on instance methods. They are just methods. You just define them this way, and that's it. There's nothing else you can do about it. Interesting. So They're not mentioning that we can kind of do private or something with probably with the underscore. And that's it. All right. It's weird that we can do like, no, but there's no like notion of private, public, or whatever, anything else. Kind of weird. All right, operators. Most operators are instance methods with special names. Dart allows you to define operators with the following names. Okay? So these are instance methods. They just have special names. Okay, so we have, like comparison. We have, I guess, tilde could be for negation. Minus, plus, bunch of divisions, percent sign, even a pipe, huh? And, like or X or ampersand doesn't end. Oh, okay. We even have like double ones and triple one only to the right. What are those? Are those like bitwise by default? Interesting. And then we have setting an index and reading an index. Okay. You may have noticed that some operators like not equals aren't in the list of names. These operators aren't instance methods. Their behavior is built into Dart. Okay, they're built into Dart. Does it mean that when we call this, it just calls this and just negates it? Is it that simple? To declare an operator, use the built-in identifier operator, then the operator you are defining. The following example defines vector addition, plus and subtraction, and equality. All right? So we'll probably get an answer about this one. So we have a vector, right, with x and y. So this is pretty much our point, but this is like an integer vector. Okay. We have a constructor, and then we have operator, space, and the actual operator. Okay, and right after that, we have the thingy. Okay, that makes sense. And okay, because this is a instance method, this refers to this vector, while this is the other vector. Okay, so we can do x plus v dot x and whatnot. We don't have to specify like, left and right operand. We have just this is the left one, I presume. And then we override the equals operator. Okay, so I presume that by default, this is implemented because we're able to compare two instances of whatever class we wanted, right? And the comparison was happening, I guess, by the reference, right? Not by the content. So in this case, we can compare it to another object. Oh, because we don't have, okay, so we can define multiples of the same operator, just like we can't have multiples of the same method. Therefore, we have to compare to an object. Ew. So yeah, basically, if it is vector, and okay, so basically return other is vector. If it's not, just do false. All right, so that already takes care of that. And if it is, we're checking if x is equal and y is equal, and therefore in one line we have, we're comparing three separate things. Hey Taras, how are you doing? I can tell you that one thing I'm upset about in Dart. You can have multiple methods with the same name but different arguments. That sucks. Absolutely sucks. What was the name for it? Not function overriding, it was function, some other name for that. And that drives me mad that you can't do that, because now if you want an operator for comparison, you need to make a single one that's like ultimate one. And compiler won't help you in making it, overloading, that's the name. Yeah, there's no function overloading, and that makes me sad. Because I would like to have different ones defined. Maybe I'm comparing it to a float vector, right? I don't want to have a bunch of branches. I want a one thing compiler, which is a good one for me. Yeah, that's like this is like literally the one thing that upsets me about the language. Other than that, it's awesome. And maybe the constructors are a little wacky. It's just too much. All right. So we've got this one, and we're also overriding the get the hash code. And okay, so we have implementation of the hash code. Same as, okay. Why are we using that? Is something using that we won't be doing? Because it looks like it has a default value, right? Why are we overriding it? It's not mentioned anywhere. Looks like we won't even have it explained. That's weird. And then we have an example of usage. So we have vector first, vector second. You can see that they are different. So v1 plus v2, and the plus will actually run this code. So they should be added. Bam. In comparison, oh, I mean, we're using comparison here. Okay, that makes sense. It's simple. Task says it started as Dart as JS 2.0, as in JavaScript 2.0, and probably comes from there. Okay. Technically, they might be able to do it if they want to. Oh, of course they could. And CPN says, what is function overloading anyway? So function overloading would be simply, let's say, I will literally copy this code, right? Let's just paste it here because function overloading is like the thing I absolutely love. Some people hate it, but I love it. So let's say that we would define a new function in this vector, right? Something like, instead of doing the operator, let's do something similar. Bool is equal, okay? Something like is equal. And this is equal will be running on this vector. So we have this, but we're comparing it to vector the other vector. And I could have, a comparison here. Simple as that. Return, bam. So we're basically checking if x is x and y is y. If it's true, then yeah, they are equal, right? And then if I had, let's say that this vector here, this is the vector int, like integer vector, all right? That's what we're gonna call it. Let's just rename everything here. But then maybe I also defined, just because I'm making a game, right? Something similar where I have class vector float, and I have pretty much the same thing, but the only difference is that everything is a float. So, wow, those tooltips are gigantic. And this will be float or double, whatever. Sure, double. db up. So in my equal now, this will work only with vector integer. With overloading, I can basically say, you know what? I'll define a second method that is equal. But this one will be for that compares this vector integer with vector double. Okay, other. And therefore, I can have some custom logic here. Maybe I'll just always return false, whatever. But I basically can have two functions, in this case, two methods, with exactly the same name, but different arguments. In this case, they are differ with what type is being allowed. And therefore, somewhere in my code, if I'm gonna say, I have whatever, final v int as vector int of whatever 2 and 3, right? And I have final v double, 2.0, and 3.0, I can basically say, hey, print that v int is equal to v double, right? If I would call this, the compiler would know that, oh, you're calling something on v double, so it's gonna choose this method. If I would call it on itself, right, it will know that, oh, I need to choose this one. Therefore, I can have many separate ones. And this is kind of fun because, especially with constructors or some other things, you might have one function with, like 5 parameters, and then maybe you have one the same names, but with 3 because other ones were optional. And nothing stops me from going like here that, oh, we're just gonna compare object, but that means that your code needs to have those checks in here. Is it an object? I mean, is it int? Yes, then run this code. Is it not int? Run this code. And basically have this additional bunch of code that will run every time, absolutely every time you do any comparison. Well, in this case, when you have overloading, compiler during compile time will actually choose which one to run. Therefore, there's no like runtime check. That's my opinion. This is like, yeah, extra overhead. Yeah. And there's just so many uses for that. Sure, it makes code confusing sometimes if somebody's not used to it, because like, oh, which one do I, like you start typing a function and you have like, oh, there's 16 definitions of it. But with tools, you can get through it. I don't know. Oh well, let's get rid of, we don't need that example anymore. Yeah. I'm upset at Dart. And CPN says, Zig solves, Taras says, Dart has optional arguments and named arguments and default values for arguments. In my opinion, that is enough overloading. Yeah, but then still have to manage and make a function that is overly massive because, oh, I need to handle in case this is no, or in case this is that, in case this and that, and you just end up with messy code, in my opinion. And CPN says Zig solves this by taking the type as an argument. No worries about mentioning Zig. Hey, that's what I like. I know, C#, so I mentioned C# a lot. So Zig solves this by taking the type as an argument. I mean, yeah, you can do that. You could, we haven't seen it. Did we do generics? We did generics, right? Yeah. You can do generics, yeah. But sometimes generics isn't enough because you might have vastly different logic, right? Because if I have some kind of, method that I can run literally different logic depending on what I'm going to provide. If I didn't provide a URL or something, maybe it's gonna do additional lookups or something. If I didn't do this and that, and it can kind of decompose those methods that, maybe the simple one does something and calls the more complex one. Like, just whatever. There are lots of patterns around it that it can build. Says, thing I don't like about Dart is it's hard to figure out what is the difference between interface class, base class, abstract class, abstract interface class, base interface class, and base abstract class. We'll get there. We will get there. Another thing that Dart doesn't seem to have is like a meta programming or code generation where you can, maybe it has that, it just didn't mention it. But it doesn't matter now. Let's move on because we have lots of material to cover. Getters and setters. All right, getters and setters are special methods that provide read and write access to an object's properties. Recall that each instance variable has an implicit getter plus a setter if appropriate. You can create additional properties by implementing getters and setters using the get and set keywords. So let's see how it looks compared to C#. Okay, so you do this. All right. Ew. Okay, this is not fun. This is not fun. Okay. So we have our class rectangle, right? Just have whatever values for top, left, width, and height. Left, top, width, and height. Okay, sure. Then we have a rectangle, a constructor. Okay, and then we define two calculated properties, right and bottom. Because notice that we are not storing right and bottom, we're just storing left and top, so we can, I guess, calculate those, right? So we can say that this is a getter called right that will return a double. And it basically does left plus width, right? And that will tell us roughly what the right is. While if we're doing a setter, even though it's a function, we are... Oh, wow, this is so weird. So, okay, so for a setter, we start with set, we say what property, right, or what non-existent property, then what it accepts, and then what the value we want to, basically what we want to do with it, right? Because we provided that we want to set the right to be this. In this case, it's gonna adjust the left. It's not gonna adjust width or anything. It's just gonna adjust left. It's gonna set left is the provided value minus width, right? And then we have similar for the bottom. I don't like the syntax, mostly because get is here on the right, set is somewhere on this side. It's I mean, I can see a situation that this could occur, like, oh, do all the getters first and then all the setters. I don't know, it kind of looks messy. Copy. Paste. I need to decrease that font. This is just too massive. I hope this is readable on other screens. CPN, why have getters and setters? Just have regular functions. Double get right, void set right. Oh, I mean, if you can write void, that would be great. Although at that point it becomes redundant. So can we do void set? Okay, we can. All right, good to know. So if we have this, if this was C#, I would just do right. I would say, okay, this is a double, right, and I would just say get will return whatever. It will be whatever, left plus width, right? And set, which takes the value, would be this. Sure, have the extra brackets and it would probably format it in this fashion, but whatever. Was there equals or not? I don't even remember. Usually it's code that it's half generated for you by IDE, but it's 4 lines, but I can see that I have right mentioned once. It looks like any other variable, and then I just have set and get. I don't have them separate. I kind of like that syntax a bit more. But if you can do void, even though it's some, like unnecessary word, that kind of makes it easier to scan that, oh, they are both for the same thing. Okay, that makes it a little bit more readable. Okay. I mean, syntax-wise is easy. And CPN, why not just have functions? So with functions, you need to call them by putting parentheses, right? So this is, again, something where some people might be upset or not. Notice how here, when we created a rectangle, if we want, we can just say rectangle left, compare it to 3, right? And there's no problem to do right. It acts like a normal property. I don't have to put parentheses. I don't have to say get right, right? I don't have to do that. I just do right. And the same thing is for setting. I don't need to do set right and wrap this in parentheses. It just looks like an actual property. And that's what makes it nice, because it makes code readable. Therefore, you see like, oh, this is like a property. It because it looks like a property, you're expecting that it's not gonna do anything heavy, right? And that's where the bad part is, because this hides away that you're really running a function behind the scenes, and there's nothing stopping me from doing some, big calculations here. So if I was a bad programmer and I would do that, somebody would be like, "Oh, I'm just gonna set a value, right?" Well, magic stuff is running behind the scenes. So that's the stuff where, okay, if you're using getters and setters, try to make them as light as possible. If it's something heavy, calculation heavy or whatever, then instead of doing getter setter, just do it through a function, right? Otherwise, it just gives a nice way to run with your API, because it just shows up, right? Rect.write, and I can see like a property. It's nice and fun. So I like getter setters. And CBN says it makes it clear that it's calling a different function. Having no hidden control flow is more readable and maintainable, in my opinion. You're right when it comes to low-level code. For low-level code, you definitely, and with low-level code, you will always, often, especially something like in Zig, you need to manage, like juggle many other things. Like, oh, I need to worry about memory. I need to worry about performance. All those important things, right? So hiding things away from you is like the last thing you want. And I 100% agree. Something like this for getters and setters and low-level programming would be just, it's one of those things that, oh, you can do this magic, like a NIM that's gonna do a million things behind the scenes, but it's hard to track, right? But with something a little bit more high level, where performance isn't, like, most of the time you really don't care about performance unless you're about to do something really bad. You want, you're dealing with hundreds or thousands of different API endpoints or some kind of models that are often built out, or what you worry about is how they're interconnected. You want to have an easy way to interact with those, right? So instead of what was the function for it, you see, oh, this is a property. Somebody smart in my team worked on that. And you kind of, you have code reviews and whatnot. You kind of keep each other in check. Then you prefer the ergonomy, or like, you want a language to be ergonomic at that point. And that provides that. It looks like in Dart, behind the scenes, things are happening with, what generates getter and setter. So behind the scenes, those are actually being used and generated by the compiler. So it kind of, this you could consider, oh, I have a little bit more low-level access to what the language is doing. But, at the end, it's just the API for you as a programmer. And this is resolved simple way. And I'm sure this is just getting used to how it's being written to quickly recognize the pattern. Alrighty. So with getters and setters, you can start with instance variables, later wrapping them with methods, all without changing client code. Exactly. So they are even saying that you can start with normal double left, right? And if something in the design changed, like, we need to make this thing calculate itself automatically, or maybe it needs to adjust something else behind the scenes so that our code makes sense. And there's 200 things that are using it. Instead of going and refactoring 200 things, you'll just, you know what, I'm gonna make it a setter and add extra logic in there, and no other code needs to change. Operators such as increment, plus plus, work in the expected way, whether or not a getter is explicitly defined. To avoid any unexpected side effects, the operator calls the getter exactly once, saving its value in a temporary variable. Okay, makes sense. So yeah, because it knows that a getter called twice might, I don't know, increase some counter in the background, right? So yeah. Oh, a getter is another interesting thing that you could, for example, make it some kind of analytics in the background, like, oh, how often are we actually getting this value of from here, right? And without making it into a method, because from the user perspective of your library, it's just getting, but in the background, maybe you're counting something like, oh, turns out we're never using that path or something. But yeah, this is like for larger systems often. Okay, abstract methods. Instance, getter, and setter methods can be abstract. Okay, so now we're getting a little bit closer to what Taras doesn't like. Abstractions. I know, Taras, you like abstractions. It's just, you know, we're getting into the wording. Instance, getter, and setter methods can be abstract, defining an interface by leaving its implementation up to other classes. So abstract methods can only exist in abstract classes or mixins. Okay, so basically, only within abstract classes we can define abstract methods. Okay, that makes sense. So this way we don't have any situation where we have the actual concrete class with abstract stuff, right? With missing stuff. Everything that's concrete will always have concrete implementation. It will be enforced. So to make a method abstract, use a semicolon instead of a method body. Exactly, just so we have the abstract class. This is our first time we are introduced to the abstract keyword. And doer. Doer will be just an abstract class. Define instance variables and methods, right? So we define do something, and we don't define what it's doing, right? Only then the effective doer, which extends the doer class, actually needs to implement that, right? So if I was to copy that, let's just leave that code, whatever. If I wouldn't put that do something here, right? It's compliance, like, hey, missing concrete implementation of abstract class doer do something. So we are basically forced to say, hey, boy, do something needs to have an actual something, right? We'll just print I'm too lazy. Screw you. Okay? That's what the effective doer does, right? And now it's happy. If we would make the effective doer abstract as well, then we could decide to either put implementation here or probably skip it altogether, right? Okay, that works. We can just say that we have effective doer. We didn't even define anything else. And then if we're going to do class even more effective doer, or my, sure, extends the effective doer. Now again, we're prompted, hey, you need to implement the doer do something, right? So if we would do nothing here and not give it implementation, we'll need to do both, right? Do something and do nothing. Okay, there we go. So it works as expected. All right, makes sense. Great. So let's move on to extending a class. We've went through methods. Now we're starting to go into more fun things of when it comes to classes. All right, so extends the class. Use extends keyword to create a subclass and super to refer to the superclass. Okay, so let's see how they do it, because so far it sounds like it's going to be simple. We just use the keyword super and that's it. So we have class television and we can turn it on, which will illuminate the display and activate IR sensor, right? So we just have the television, right? And then we can define a smart television, which extends television. And Sabina says all of this can be done with Go with structs and interfaces. Yes, you can do that. Go has some basic stuff like that with structs interfaces. It just has a little bit different approach. Go tries to specifically not be object-oriented language. Go wants to be, like composition over what hell was the word? Over inheritance. And that's just different approach. That's, for example, why Go sometimes it's like makes me angry. Like, hey, I want to do the OOP way, the object-oriented way. Okay. With classes, you have a little bit more that you can do than with Go's interfaces. With Go interfaces and stuff, you can kind of make those ideas of objects, right? You can have something, this you implements this in that interface, but you can't go far with that. You can kind of assemble larger things from parts of things. But with classes and object-oriented, you can do a little bit more, where the language is, you can kind of build things a bit more piece by piece and do a little bit more, swap some parts. So it's a way more complex system that allows you to do more, and therefore there are more traps that you can fall into. Okay, so class television, we have that. And then smart television will extend the television, and looks like we are overriding the turn on, right? Because we defined it here and we'll redefine it here. So what we're doing here, we're calling super turn on. So on smart television, when we call turn on, it will first run this, and then we'll additionally do boot network interface, initial memory, upgrade apps, and whatnot. SPN says Go has just enough features. Sure. I can't stand Go's, for example, generics and just lack of features. I can hold some stuff in my head. Syntax is easy to learn. In Go, there's lack of syntax, so to do things, you need to find workarounds, and therefore you gain complexity somewhere else. I don't know. Just with the for loop, right? Just the for loop. Just the fact that you don't have while loop. And okay, let's try to reuse for loop and make it overcomplicated, because now you need to, things look the same because you have for loop here, for loop here, for loop here, and now you need to look a little bit closer. Like, wait, this is not just normal that I iterate. This is like a forever loop, and it's harder to kind of look at something at a glance. Sure, less keywords, but whatever. I mean, it's the debatable thing. Recently there was a fun video. Can I find it? YouTube.com. I shouldn't be logged in here, so it'll be kind of weird, but let me look at different thing in history, because it's an interesting, point of view from somebody that went with Go, went a little bit deep, and decided, like, you know what, this doesn't work out for me. Because not saying that won't work out for everyone, because some people love Go, swear by Go, using it for years, and some people just don't. There we go. It's an ad, of course. Let's skip that. Come on. It's Go the Bad Parts from Awesome. It's an okay channel, right? I'm gonna throw in a link. Bam, and you know, it gives you a perspective because everyone has their opinions. All right. I tried Go several times and just bounced off because it seems overcomplicated for me from a different perspective. Yep, you seen that video. Yep, exactly. All right. So this is simple. We can just call super something. Looks like we didn't even need to put any override keyword on it. And is that normal, or did they just miss something? Because we were doing overrides somewhere else, so I'm a little bit confused now. Let's just do this. So yeah, this one is just unhappy because we don't have whatever void elementate display, right? And whatever void activate IR sensor. Okay, so this doesn't complain about that. We'll just grab those and do the same thing here. Bam, bam. And this will be void and just empty implementation, right? So this is not complaining. So this doesn't have to have override. What does the override do then? Annotation on instance members which override an interface member. Annotations have no effect on the meaning of Dart program. This annotation is recognized by the Dart analyzer, and it allows the analyzer to provide hints or warning for some potential problems of an otherwise valid program. As such, the meaning of this annotation is defined by the Dart analyzer. The override annotation expresses the intent that a declaration should override an interface method, something which is not visible from the declaration itself. Okay, so it's just a hint for myself and somewhere. This extra information allows the analyzer to provide a warning when that intent is not satisfied. Where a member is intended to override a superclass member or implement, but fails to do so. Such a situation can arise if a member name is mistyped or if the superclass renames the member. Oh, so basically, by me putting override here, if I by accident put this ONN, right, it will tell me like, oh wait, this doesn't override anything. You might have screwed up. Or maybe this was refactored into turn off. And suddenly I'm getting an error like, oh wait, this was supposed to override something. It doesn't now. So the LLM would see that and it's like, oh, I forgot something. Okay, so this is like totally optional. Good to know. Good to know. All right, so this makes sense. Tara says Go is perfectly balanced programming language. And CPN agrees. Okay, sure. Overriding members. So some classes can override instance methods, including operators, okay? Getters and setters. Okay, so we can override getters and setters too. That's good to know. You can use the override annotation to indicate that you are intentionally overriding a member. So at the television with the contrast, right? And here we can do override contrast, right? An overriding method declaration must match the method or methods that it overrides. Or methods. What, plural? That's confusing. That it overrides in several ways. The return type must be the same, right? The parameter types must be the same type or a super type of the override. Oh, so you can do basic super types, right? Okay, just like here. Oh, I see. So television will specify an integer while the very specific television widens it to a number. That's interesting that it widens it. I guess, okay, it still allows to use it as a television because it will accept everything that television was accepting. So that's good, but just in case we want to handle floats here, we can, and we just need to make sure that internal we do it correctly. So, okay, that makes sense. Okay. And there we go. In the preceding example, the contrast setter of smart television changes the parameter type from int to a supertype number. Okay, that makes sense. If the overridden method accepts n positional parameters, the overriding method must also accept n positional parameters. Okay. A generic method can't override a non-generic one. And a non-generic method can't override generic one. Okay, so basically when I have generics, it still needs to match. Okay, that makes sense. I can do that. I wonder if this something does something with like named optional parameters or something. But I don't feel like going deep into that right now. That's something we can try out and practice if we ever need it. Okay. Sometimes you might want to narrow the type of a method, parameter, or an instance variable. This violates normal rules, and it's similar to a downcast in that it can cause a type error at runtime. Still, narrowing the type is possible if the code can guarantee that a type error won't occur. In this case, you can use the covariant keyword in a parameter declaration. For details, see the Dart language specification. Yep, I hope we'll never need to use anything covariant because it's just weird. So, yeah, but just in case we can override stuff. Okay, if you override the equals, you should also override object's hashcode getter. Oh, finally getting explanation why the thing was done. For example, for an example of overriding equals and hashcode, check our implementing map keys. Okay, so we saw that already, right? So I presume that because we're overriding the behavior of equals, in case we are in case we want to then throw that object into some kind of map will try to use those the hash code for keys to optimize it, to optimize things. We need to do that because normally I guess the hash code is generated from the object's default comparison way, which is by reference, some kind of ID, like a pointer, right? But if we're gonna implement our own that maybe does comparison depending on some kind of values, then we might want to change that, right? To make a lookup quicker, and this way we can compare things quickly, like, hey, find me object of this. And both are getting turned into a hash code, and that's how the lookup happens. Okay, so good to know. I wonder if that will give a warning or something. That would be fun. All right, no such method. To detect or react whenever code attempts to use a non-existent method or instance variable, you can override no such method. To detect or react whenever code attempts to use non-existent method. What? So class A. Unless you override no such method, using a non-existent member results in a no such method error. But here we can just do something. Oh, I wonder if this is to use like with dynamic or something, where we can detect that something tried to invoke something and we can handle it gracefully. Otherwise, how on earth would that work? You can't invoke an unimplemented method unless one is... Okay, so that's about... You can't. Okay, so this is the explanation, right? So you can't invoke an unimplemented method unless one of the following is true. The receiver has the static type dynamic, right? So that's what I was saying. We're dealing with a dynamic object. We don't know what it is. We tried to run it and oopsie happened, right? Or the receiver has a static type that defines the unimplemented method. For example, abstract, right? And the dynamic type of the receiver has an implementation of no such method that's different from the one in class object. Confusing, okay? Doesn't matter. Basically, if we're dealing with dynamic, we can implement, hey, no such method and handle it in some way, right? Let's say, what tried to be accessed. I guess it always has to return void. I guess. Okay, we can just do like absolutely nothing, or just print it out, error it out, or maybe, I don't know. We can't return anything, so that's too bad. Unless we can do something with invocation, but I don't think so. For more information, see the informal. No such method forwarding specification. It's an informal one? Okay, so it's basically from GitHub from 5 years ago. Okay, it will be nice to kind of save for later. Interesting. Interesting. Just a second. Alrighty. So let's get back to our documentation and we jump over to mixins. This one will be a little bit longer, but probably not too much. Okay, we have a good pace, right? Not even an hour and we're already past two things. Okay, mixins. Mixins are a way of defining code that can be reused in multiple class hierarchies. This is very nice because I can see it as interfaces that have something already included, but maybe it's even better. They are intended to provide member implementations en masse. Oh, so maybe that's like partial implementation of interfaces? To use a mixin, use the with keyword followed by one or more mixin names. And Taras is excited. He likes mixins. The following example shows two classes that use or are subclasses of mixins. Okay, so let's see. We have class musician that extends a performer, right? With musical. So I guess musical is our mixin, right? And then we have class maestro, which extends a person, right? But also has with musical. Okay, so maestro is also the same, I guess, implementation of something, but also has like mixing of aggressive and demented, right? Because he's like total maestro. Great. So maestro will create maestro with his name, and name is that, and can conduct is true. Okay, I guess those details will come in handy. So to define a mixin, and of course we can see that we can we can throw 3 mixins into the mix. All right, and Tara says also most of Dart's language design happens on GitHub, so you can follow it. Okay, just like C# is on GitHub, I believe, and yeah, several other languages. Yeah, GitHub is a common place to have all the RFCs and whatnot. Alrighty, so to define a mixin, use the mixin declaration. In the rare case where you need to define both a mixin and a class, you can use the mixin class declaration. Okay, so now we just learned that if we have mixin class, that means it's just both. It's not some special version of a class, it's just both at the same time. All right, that makes sense. Interesting option, to be honest. I guess it saves you a step of, oh no, it just makes the class reusable in some other way. So this is very interesting. Mixins and mixin classes cannot have an extends clause. Okay. And must not declare any generative constructors. Oh, okay. Generative constructors were the ones that, like this one, right? Yeah. Or maybe not. Because this one just takes a value and we can set it manually. Oh, we can do that. Those constructors just drive me nuts because they're so confusing. Maybe I'm just missing something. That the documentation of constructors was absolutely horrible. Okay, so let's see. So we define a mixin musical. All right. It has 3 fields. all seem to have default values. Then, and can play piano, can compose, and can conduct. By default, none of those. And then we have void, entertain me, which is just a function, right? Method, let's say. I guess it's still a method even if it's on a mix in. So if can play piano, we just playing piano. Otherwise, waving hands. And otherwise, if it can't do anything, neither compose nor play piano, neither conduct nor play piano, it's just gonna hum to themselves. So it will fail at entertain me. Okay, so basically a mixin can provide a set of fields and some kind of function. Therefore, looking back at here, if we just define a musician extends, a musician that automatically gets all those three fields and a function with an implementation that uses those. And looks like, I'm assuming that a mix in, all the functions here or methods can use only fields from within here. So it needs to be self-contained, I presume. And CPN says, I'm lost. Okay. So think of like this mix and musical, like, in interfaces in Go, right? You can define that, this is some kind of fields in there, right? Some data and maybe some function, right? And you can say on a different interface that it implements it, right? Therefore, all those fields will be brought in and a function will be brought in as well, just no implementation. So what this does, a mixin does, we can kind of, we're defining the same kinds of fields and maybe functions in several places. We can kind of compose them in a similar way. It's just with classes, you have hierarchies. In Go, you don't have hierarchies. Yeah. And Taras says Dart classes were designed by a guy who wrote JavaScript engines, so it kind of shows. Okay, we've got flexibility, right? But as long as it's, so far I like Dart's type system because it's like C# one, the one that gives you safety and you feel comfortable with, right? Because it actually ensures it's not like TypeScript where it's going to pretend that something works and then it doesn't. Or you need to, spend 3 days to make it work. Here it just seems to work. So if it works with mixin, that's great. And just the fact that we don't have to copy paste code 30 times. So the mix-ins so far, they seem like a little bit of composition that still integrates with inheritance stuff. So that's kind of fun. So in this case, even though musician is extensive performer, which probably isn't even a person, it's a completely different hierarchy. Maybe, in domain-driven design, you would have completely separate hierarchy for let's say, for orders from the perspective of a warehouse, and completely separate set hierarchy of stuff from the perspective of, let's say, sales, right? Because in domain-driven design, you would need to, it says like, okay, you cannot share objects. If you have an idea of an order from the sales perspective, an idea of an order from warehouse perspective, right? The people who package or people who just collect money. These need to be separate objects. And if you want to convert from one to the other, you need to have a separate method that will translate from one to the other. And this basically makes sure that whoever works on code from the sales perspective uses all the sales lingo, while people in the warehousing use their warehousing lingo, right? Because the application is massive and you can have subject expert here, and things can be understood without being confused. Like, okay, in order, do I need this data here? Do I don't? But whatever. But it looks like with mix-ins, some of, instead of defining this from completely from scratch and that from completely from scratch, you could kind of reuse parts of it, right? Maybe the common parts would be defined in both, and you don't have to deal with an interface that will force you that, oh, you need to roll your own implementation everywhere, or deal with something like, oh, we have a common class and suddenly, oh, we can't inherit from multiple classes and nothing works. We just have literally composition, and this is self-contained, so it's not going to destroy anything because it can, a function here can refer only to stuff that was defined in here. So this is, and Vue.js, for example, has the same concept of mixins. So this is fun. I like that. It's a good concept. Okay. And we know that mixins cannot have an extends clause. So you can't derive a mixin from a different mixin. But I wonder if you can do mixin musical with some other mixin, because I think it would make sense to use mixins within mixins. We can probably say that because they didn't say that we can't. And CPN says, can you have just the function declaration in mixin? I think so, but the problem would be that without implementation. Well, let's try it. Let's see if it allows us to make an abstract mixin. All right, so we have our musical, right? This is our mixin. This we can get rid of. So we have our mixin. And can we do abstract mixin? Can't have modifier abstract here. Ooh, we cannot. So probably we can't do that, right? Oh, we can? Okay, all right. So what does it look like when we try to use it? Maybe it will be just like, okay, you need to implement it. Class, I don't know, person, right? With musical. And now it says missing concurrent implementation of mixin, musical, object, and termi. So you can. So a mixin is beyond just, like for example, from a C# perspective, an interface so far, like in a classic way, can define only like, what's a getter function, what's a setter function, or what, like there needs to be a setter, there needs to be a getter, or there needs to be a function such method, right? And none of them can hold any implementation because it's just something. Here, you can actually add normal fields and probably getters and setters as well as functions that don't have implementation or have an implementation. So that's kind of fun. All right, so you can do whatever you want. And there says base mixin or interface mixin. So I guess interface mixin, I presume, will complain if I were to have the, let me just undo the stuff, right? Let's just get to this. All right, what if I'm going to do interface mixin? Mixins can be declared interface. Oh, you can't do that. Base mixin? Okay, you can, but I don't know what that means. No documentation. Oh well, we'll learn. Okay, that's fun. Thank you, CPN, for asking that questions. We just learn more. All right, so specify members. A mixin can call on itself. So sometimes a mixin depends on being able to invoke a method or access fields, but can't define those members itself, because mixins can't use constructor parameters to instantiate their own fields. Mixin depends on being able to invoke a method or access fields, but it can't define those members because mixins I mean, we can't have a constructor on a mixin because it's not a separate class. It's not a class definition. So it wouldn't make sense for it to have a constructor or force you to have a constructor. I mean, you can define fields that it can call on itself, in my opinion. We just have an example here. Hey, it defined fields and calls them, right? So that don't know what the hell they're talking about. The following section covered different strategies for ensuring any subclass of a mixin defines any members the mixin behavior depends on. Okay, so we have the first thing, right? Define abstract members in the mixin, because we just checked that. And CPN says, oh, just mixin means interface mixin? I don't think so. So far, we didn't have much of explanation. What is a class, what is a mixin, and what is an interface? Because it looks like you can have interface class, but you can't have just interfaces. Confusing. Declaring an abstract method in a mixin forces any type that uses the mixin to define the abstract method upon which its behavior depends. So this kind of acts like an interface, right? We had the musician, play instrument, right? That's our mixin, musician. You have play instrument without anything. So it's an abstract method, right? So our virtuoso will need to implement it themselves. It will be forced, just like in a normal interface. But beyond what normal interface can do, that mixin will also provide play piano, which will utilize that play instrument, and play flute, that will also utilize that play instrument. Even though it doesn't really implement that, it just has the definition. So, you know, by the time we are mixing it into our virtuoso, which provides that implementation, we'll be able to do stuff, right? So if I'm gonna copy this part, I should be able to literally go and say, hey, final virtuoso is, we don't have anything, so it'll be new virtuoso, right? We just created a new instance of this class, right? So we can do virtuoso dot, and we can play flute, we can play instrument, play piano. All those are implemented. Instrument is implemented here, but the piano, right, when we call it, it will just place the something beautifully. In this case, it will say plays the piano beautifully, right? We're gonna try to run it, and it will be dart run function start, right? Plays the piano beautifully. Okay, so virtuoso was forced to implement play instrument because of musician, and then we are calling the thing that was brought in from the mixin. So kind of goes both ways. Okay, I can see it's a nice composition pattern. Alrighty. Access state in the mixin subclass. So declaring abstract members also allows you to access state on the subclass of a mixin by calling getters which are defined as abstract on the mixin. Okay, so we can say, hey, our mixin name identity, right? Just defines that, okay, I need to have a getter for a field called name that will return a string, okay? So again, very similar to interfaces. And then we, I guess, oh, wow, okay, this is interesting. We're specifying that also the hash code will be this thing. So I guess when we apply this mixin onto a class, it will automatically override its hash code implementation. Oh, right, it's a getter. Interesting, and we just specify it here. And it will also override the equals operator. Wow, okay, this goes beyond that. We can actually override stuff that's already present in a class. So when we do class person and we do with identity, we need to provide that, oh, we have a name, right? It can be final because all we need is a getter, And final allows you to read it however many times you want. It just doesn't provide a setter, so we don't care about setter here. That's great. So this will just reuse that and magically override those two inside a person. Okay, so this is nice. This is nice, yeah. Okay, this is powerful. And CPN, I'm sorry, but you will be probably very confused if you're not familiar with open objective programming and how classes are supposed to work. Okay, this is fun. All right. I like that. So what are other superpowers? But how far can we push it? I want to know, how far can I push it? So let's reuse that example, right? We have the name identity that is supposed to override this and that. So let's say that we have a class entity, right? Living entity. And this will be our class living entity, which will basically, I don't know, have a final string name, right? This will provide a name. And then it will also provide something like, I don't know, void introduce self. Okay. And what it's gonna do is gonna simply do print me is name, right? Like broken English or something, right? It can do that. Or like maybe it doesn't even have that. Introduce self. It's gonna say me. I am me. And a living entity, we can say, oh, I'm me. Introduce self, right? So something like name identity here, we can say this extends the living entity, right? So we already can call introduce self, right? So if we're gonna do our virtuoso, which will be a person with some kind of name, let's say Greg, we can say, hey, introduce self, right? And it should just say me is me. I am me. There we go. But we can probably say that, you know what? We need to specify. I want to check the override here. Void introduce self. And we're gonna say it doesn't take anything, but the implementation will be simply print I am and the name, right? Because the name is supposed to be from here. So now when I run this code, because this person has the mixin applied, this should override thing from living entity. So let's run it. It says I am Greg. So now I can see that if we would say not a person, maybe, I don't know, robot, that doesn't extend from the living entity, therefore it doesn't have the implementation of introduce self. It's completely separate because it's not living, right? But we still specify that it has name identity. It should still have this added, not just overridden, but added, right? So we can say final robot is new robot with a name, I don't know, 3CPO. Right? And we do robot introduce self. We can still call that, right? So they both can use that mixin. But if I would say it's override, I guess now we'll be unhappy because, oh, method doesn't override and inherit the method. Try updating. Okay. If I would delete this one, it's still not. Okay, so override basically says is allowed only to use for like default object stuff. Interesting. Steven says, no way, I am me too. Yep, I'm just pushing it, but okay. So override works only for things that are already implemented. And because it's an option, I mean, I guess mixin operates assuming that it's just any object, because everything needs to be an object. Therefore, these make sense. But if I would change the hash codes, it just says, oh, sorry, doesn't match the superclass. But because mixin doesn't allow us to, on. Okay, on robot. We just discovered something. So name identity can't be a super interface of itself. Okay, this is so confusing. Why does it call itself interface? Okay, now it. Okay, I'm not gonna mess with that right now because, oops, this is very confusing. Let's keep reading. But okay, I just like that we can override stuff. All right, implement an interface. Similar to declaring the mixin abstract. I mean, we didn't declare it abstract. We just, one of its property was abstract, right? Putting an implements clause on the mixin while not actually implementing the interface will also ensure any member dependencies are defined for the mixins. Okay, so this is the first time we see an actual interface. Look at that. Abstract interface class. So this is like the most classic example what an interface is, right? It's abstract as in doesn't provide any I guess isn't even allowed to provide any declarations like any bodies of anything. Everything is just a definition. And it cannot provide any what was the word? Any implementations, right? Concrete implementations. It can only provide definitions. So we have the interface called tuner, okay? And then we have a mixin that implements tuner, right? We don't have to provide the tune instrument. We can use it, and then whoever will mix this in, it's as if we had with guitarist and implements interface, right? It's just instead of writing both, this basically forces us to do it. Okay, so again, more composition. I can see that. And CPN says, finally something I'm somewhat familiar with. Yep. It's just you can see how much you can build on top of that, right? Various variants and things like that. This is a little bit extreme here, so I find it interesting. Huh. Okay. So we can see that even though the this mixin guitarist doesn't implement it, we can use it because whenever we are going to actually apply the mixin to something, whoever we apply it to will be forced to implement that, right? So our punk rocker, which is a guitarist, is forced to implement the tune instrument. I don't know why it's saying override. I guess just to make sure that this is overriding a non-existent implementation. Maybe just the mark that it's not coming from here, it's just coming from somewhere else, right? That's all it is. And yeah, there we go. Okay, makes sense. And now we have the magical on. Use the on clause to declare a superclass. The on clause exists to define the type that super calls are resolved against. So you should only use it if you need to have a super call inside a mixin. Okay, so this is starting to be very confusing, but I think this will limit basically what we can apply the mixin on, I believe. So the on clause forces any class that uses a mixin to also be a subclass of the type in the on clause. If the mixin depends on members in the superclass, this ensures those members are available where the mixin is used, right? So we can have a class of a musician, right? Just a musician that has some kind of musician method, doesn't matter what it does, it just has a musician method. And then we define a mixin, musical performer, okay, on a musician. So suddenly this mixin kind of already inherits from the musician, or it's like, okay, this will be basically, we'll be able to apply that mixin only on classes that inherit from the musician. Therefore, within the code here, where we are ensured that we can call the parent class, musician method, whatever, right? We can call it. And therefore, we can kind of structure things a bit more. So we have like two hierarchies that we can kind of mix in. Very interesting. Makes sense. I don't know how to explain it. Okay, so our perform method basically uses the musician method from this. So now we have the singer dancer extends a musician with musical performer. So basically, singer dancer is a musician class, right? So it's a subclass of the musician. Therefore, in theory, it already has that musician method. And then we are mixing in the performer, which will just allow it to perform as well. Okay. And suddenly we combine those two. So in main, we can call performer method that will comes from here and uses a method from here. There we go. So very interesting, especially that we can allow multiples of those to be applied. So very interesting. This could be interesting in game design, actually, because in game design, those object-oriented concepts often are just too limiting. That's why in games you often want to have some way to describe composition, like compose things. That's why things like, and the ECS systems, entity, what the hell? We had entities, we had systems, and then we had the data itself. Control. What the hell was the name of it? Yeah, entity component system. Yeah, something like that. Which allow you to do like a lot of composition. So this sits somewhere in between. Very interesting. Huh. So in this example, only classes that extend or implement the musician class can use the mixin. Because singer dancer extends musician, a singer dancer can mix in musical performance. Okay, so we basically can kind of limit what the mixin can be applied to, and therefore use those things within a mixin. And they are saying like, hey, use this on only where you actually call the super to whatever, but I can see it as a tool just to limit it to future-proof, I guess. Because the mixin is intended to be used only in this and that case. Therefore, if we're going to limit what it can be applied to in the future when the mixin maybe expands, modifies, and actually needs to access something from the base class, then you're not gonna have a situation like, oh, you know what, this code can't use that mixin anymore. Something. So okay, that makes sense. So now we go to the fun part. Class or mix in class, right? And this is like one of the later features. So a mix-in declaration defines a mix-in. A class declaration defines a class. A mix-in class declaration defines a class that is usable as both a regular class and a mix-in, with the same name and the same type. Okay, so they are also considered literally the same type. That's interesting. That is interesting. So yeah, so we can have like a mix-in class musician. So we can create our novice and apply a mix-in, whatever was defined here, into here, and it's fine, right? Use musician as a mix-in, or we can define novice, which extends the musician, therefore it's a part of that hierarchy already. Yeah, I can see that. This is kind of fun. I'll need to see in practice how that works out, and when is it being useful. And something tells me something like those mix-ins and how you can do this stuff. That's something that I guess Flutter uses extensively, because that could simplify some. I can see it, being powerful enough to simplify lots of concepts in designing interfaces where sometimes things have multiple roles, right? And CPN says, "Okay, bye, good to go. All right, thank you for joining me, and enjoy whatever you'll be doing." Okay, and the restrictions that apply to classes or mix-in also apply to mix-in classes. So mix-ins can have extends or with clauses. Okay. Mix-ins can't have with clauses, so you can't have a mix-in with a mix-in. That's interesting. So neither can a mix-in class. Okay. So suddenly that class can't have other mix-ins. Interesting. And classes can't have an on clause, so neither can mix-in class. Yep, that makes sense. So really, you can't have a mix-in within mix-in? That's our mix-in identity, right? Can I do mix-in has name, whatever, right? Let's say it defines just this contract, nothing else. So I can do with has name. Okay. So mix-ins literally are just one-off, cannot have their own hierarchy at all. They're just self-contained little bits that you can mix into stuff. You can't make a mix-in based on other mix-ins. But you can have mix-in that, what was it? Implements an interface. Yeah, mix-in can implement multiple interfaces. So now the question is, can we implement only abstract interfaces, or can we implement non-abstract interfaces as well? We haven't learned about those yet, because for some reason they just are reluctant to show us any interfaces. So we have our abstract interface and whatnot, right? That's good. What if we're gonna make it non-abstract? Then it complains that it must have a body. So let's give it a body. A tune instrument, print. I think it's already in tune, right? That's it. And we can't do that. So suddenly the tune instrument is here, therefore we don't have to have it here. Or no, we do. Punk rocker, missing concrete implementation of interface class tuner tune instrument. But we have the implementation. What the heck? We didn't lose it anywhere. But yet it still says that we need to do it. Okay, so what? I guess whenever applied to a mix-in, we're losing the actual implementation? That's weird. Very, very weird. Don't know. We'll see. But okay, we survived mix-ins. It was mighty confusing. Okay, so implements is removing implementations. I see. I mean, I can't use extends on a mix-in, all right? Because the mix-in that implements the tuner, right? We don't have it like that. Okay. All right. So I can see that this interface class is similar to something that we have mixing class. It's just when I'm looking at that, I can see that there's nothing about interfaces around here. It's like, what the heck? What does interface do? It's like they skipped entire idea of an interface. Oh well, let's go to enums. So enumerated types. Tara says, I think interface is a visibility modifier. That would be the craziest thing. Absolutely craziest thing for an interface to be a visibility modifier. What the heck? I need to learn. Please explain what the interface keyword does in Dart language. I'm confused as when I do. Wait, I actually want to try something. What if we're gonna have the tuner, right? And we're gonna create class, maybe up here. Class, whatever. Person, right? Implements tuner. And it already complains that I need to implement it. Okay. But because it's a class, I can probably do extends. Okay, I can do both. Huh. But what's the point of interface if I can... Wait, implements. Because I can remove interface. Because tuner class already has its own default interface. What the heck is the point of it? I'm confused as when I use implements with an interface, no matter if it's abstract interface class nor interface class, it always strips out the implementation. While if I use the interface class, whatever, via extends, there's no point to it as every class provides its own interface implicitly. Right? Like, I don't know. Maybe it's gonna come up with something. But I also want to say, can I just do interface tuner? No, it has to be a class. Variables must be declared using the keywords const. So this thing is a variable now. Okay, so far interface has no proper use. If that's a visibility thing, it's very confusing. You're right to be confused. The interface modifier in Dart is subtle and works differently than traditional interfaces in languages like C# or TypeScript. What interface actually does? The interface modifier is a restriction on how a class can be used, not about defining a traditional interface. Okay, so we have interface class vehicle. This class can only be implemented. not extended outside of its not extended, at least outside its library. Oh. What? Okay, so if another file, as in library, tries to class car implements vehicle, it must provide its own implementation. There's no inheritance, right? This would be error outside the library. So class truck extends vehicle. Okay, so we basically can't extend from vehicle outside of this file. Okay. So interface is a package level visibility modifier. What the heck? This is truly bizarre. Because in normal classic interfaces, you can extend them however you want. So basically, by using the word interface, it doesn't make any sense that it's an interface. It's like, we need a keyword to kind of make this thing. Let's find random one. Let's use this one because we haven't yet. What? Key points. Interface class means can only be implemented outside its defining library. What? Can only be implemented outside its defining library. Yeah, then it can be implemented, but it cannot be extended. Yeah. And then we have abstract interface class. Same restriction, but also can be instantiated. Okay, yep. Okay, because this one we can somehow instantiate because it's a normal class. Okay. Inside the same library, you can still extend this. So why this design? This is about an API stability. When you mark a class as interface, you promise the public API the method signatures, right? So it's gonna... Okay, you don't promise the implementation details, all right? And library authors can change implementations without breaking consumers. Okay, they just can't extend from it. Because it's not a class anymore, it's kind of becomes an interface. This can only be implemented, not extended outside of the library. So this is very weird. Why can't I extend it? So why this design? Yeah. So library vehicle Dart, we have class engine, right? We have an implementation detail of, I don't know, some kind of field and maybe get power that will calculate something, right? No big deal. And then in consumer code, it only depends on the signature. It doesn't depend on the thing. Okay. So comparison of C# TypeScript, unlike C# TypeScript interfaces which define contracts, Dart's interface is more like C# sealed modifier. Yeah, exactly. Sealed means that you can't extend from it, period. No matter if it's inside or outside. It's about control and inheritance. Confusion comes from Dart's design where every class implicitly defines an interface. The interface keyword doesn't create interfaces, it restricts how the class... Still confusing, like what the hell? The word is bad. And Dara says, yes, I know. They run without interfaces for a while, allowing interface-like behaviors. And suddenly they needed a visibility modifier. So they are like, yeah, let's use interface name. So in case of Dart, the word choice of interface is pretty much misleading. What the hell? I can't spell. Let's be reassured about that because it's gonna agree with us, right? Absolutely, you've hit the nail on the head. The interface keyword in Dart is terribly misleading for anyone coming from traditional OP languages. So what it should have been called, either sealed like in C#, final like in Java, but that's taken in Dart, non-inherit, or implement only. What we have would be clear. Implement only class vehicle. Can only be implemented, not extend. So why this name is disaster? Dart's design philosophy of every class as an interface created this mess. They wanted to restrict inheritance patterns, but couldn't use traditional interface syntax since classes are interfaces. So they repurposed the interface keyword for something completely different. Okay. So yeah, inheritance restrictors. There we go. It's just funny. There's also a similar thing with base. Okay. I think Claude is also confused. Yep. It's just don't use interface keyword and you'll be good. That's how I see it. Just ignore, imagine interface doesn't exist. You don't need to use it. All right. So let's go to enums because I think enums might be fun. Maybe this would be one language that actually does enums correctly. Because it's like, I don't know why languages can't get enums right. Okay. Enumerated types, often called enumerations or enums, are a special kind of class. Oh, of course, a class, because everything's an object, right? Used to represent a fixed number of constant values. Okay? A fixed number, so we can have enums that will grow, right? Note, all enums automatically extend the enum class. Okay, so we have an enum class, which, wow, this is bright, which actually has a bunch of properties, right? Some index and name, runtime type, some methods, not much, operators. Okay, so it's just like any other class, everything's inherited, but it's just whatever. It's an abstract interface. Okay, that means we can't inherit from it. But yet, by defining an enum, we are inheriting from it? What? So they are also sealed, meaning they cannot be subclassed, implemented, mixed in, or otherwise explicitly instantiated. So they are extending the enum class, which is not extendable because it's an interface. Abstract classes and mixins can explicitly implement or extend enum. Abstract classes and mixins can explicitly implement or extend enum, but unless they are then implemented by or mixed into an enum declaration, no objects can actually implement the type of that class or mixin. Whoa, okay, let's not go that far because this is not a confusion point. Declaring simple enums. To declare simple enumerated types, use the enum keyword and list the values you want to be enumerated. So if enum color, okay, so we have keyword enum. We name it color and we give it 3 values. Okay, great. Tip, you can also use trailing commas when declaring an enumerated type to help prevent copy-paste errors. Beautiful. Declaring enhanced enums, okay, so because this is simple, but enhanced enums, right? Dart also allows enum declarations to declare classes with fields, methods, and constant constructors, which are limited to a fixed number of known constant instances. Okay, I like that because I don't know about fields, but with methods, yeah, you don't have to resort to an extension methods like you would in C# to, let's say, extend an enum type. You can just slap it on there and be happy with. Constant constructors, I guess I can see that working, as in you provide multiple values, I will evaluate to one of the values, so that's fine. To declare an enhanced enum, follow a syntax similar to normal classes, but with a few extra requirements. Wow, that's a lot of them. Instance variables must be final, including those added by mixins. Okay, so we can use mixins within enums. Okay, there's some limits for it, but you can do that, right? And those mixins can provide other parts of enums, okay? Okay, that makes sense. So instance variables. All generative constructors must be constant, okay? Factory constructors can only return one of the fixed known enum instances. No other class can be extended as enum. Wait, no other class can be extended as enum. Oh, can be extended as enum is automatically extended. Okay. There cannot be overrides for index, hash code, the equality operator, okay? Because it's an enum, right? It will be taken care of for us. A member named values cannot be declared in an enum, and it would conflict with the automatically generated static values getter. All right, so there's some values behind the scenes. I guess to just get all the values of an enum, right? And all instances of the enum must be declared in the beginning of the declaration. And there must be at least one instance declared. Instances. Okay, let's see. Instance methods in an enhanced enum can use this to refer to the current enum value. Okay, just the value, because we need to remember that I guess it doesn't have extra fields or something. It's just the whatever. Here's an example that declares an enhanced enum with multiple instances, instance variables, getters, and an implemented interface. Okay, so this is gonna be large, right? So we have the enum vehicle, which implements a comparable vehicle of a vehicle. Okay, so okay, they're just throwing us into deep waters immediately. So I guess these will be the possible instances of it, right? So we have the vehicle can be either car. Okay, and look at that, because we have fields, tires, passengers, and carbon per kilometer, right? So we defined 3 possible values. A car, which will have the field tires set to 4, passengers to 5, and carbon per kilometer 400, right? Then we have a bus, which will have 6 tires, 50 passengers, and double this, and that which will have something else, right? So, all right, that makes sense. And then we have a constant vehicle. So this will be a constructor that basically has a bunch of name parameters. We're going to specify the tires, specify passengers, and specify carbon per kilometer. Doesn't mean that we can specify whatever value we want, or will it be only possible to specify a combination that matches an existing instance? That's the question here. And then, we have definition of those fields, and we have a getter, carbon footprint, which will be basically saying carbon per kilometer divided by passengers, round it up, and that will be, okay, just simple calculation, simple getter. That's fine. Nothing crazy here. We have another getter that will use this value, right? This is vehicle.bicycle. Okay, so this will be basically one of those words, the actual value, and therefore we can compare it. Is it a bicycle? And then we override the compare to. Okay, this is interesting, right? We don't have the, wait, does the enum implement compare to? No, it does not. We have compare by index or by name, and this is like a just static enum. So no. So what we're overriding it from? Does normal object have like a compare to that we're overriding? That's different than, double equals. So override the compare to other vehicle, and basically, this will be compared. So we'll return value between, 0, 1 or negative, right? Where it is for sorting. And it will be sorted by carbon footprint. So weird. I want to see how I can use it, because this is somewhat somewhat confusing. Especially that this is like the only example. Like, what the hell? So okay, it doesn't got any errors. So I assume that I can say, final vehicle, right, will be holding the value of vehicle dot, and here I have bicycle, bus, or car, or I can list all of the possible values, which is nice that we have it here. So we're gonna do car, right? So let's say, I don't know, Toyota, right? Will be car. Then we have final something is vehicle, and I want to be able to specify stuff here. So I should be able to specify the values, right? So it will be tires 5. um Tires 5, then we've gotta get passengers will be -1, and carbon per kilometer will be 5. And it's gonna complain because generative enum constructors can only be used as targets of redirection. Try using an enum value or a factory constructor as targets of redirection. Okay. So in theory, defining this, the only reason here is that we can use it this way. If I would do this, oh, so these are using it. Okay, so these are the users of this one. Behind the scenes, it just creates those that calls the generative thing. But in theory, I could do oh, because these are constants too. So it can have only constant ones. Can I do non-constant like vehicle dot whatever, right? And we're gonna give it tires and passengers, and we're gonna whatever. This needs to be integer and integer, right? Doesn't complain yet. And we can say tires is whatever. This the tires is tires. Can I do that? No. What the hell? What the hell's going on? All generative constructors must be constants, and factory constructors can only return one of the fixed known enum instances. Okay, I see. So I mean, as redirection, that means I should be able to call vehicle tires, whatever. Doesn't matter. It's pushing it. But okay, so this is being used by that. And these fields are just here, and we have some extra methods and some compared to whatever. Okay, that makes sense. Simple enough. You can just add the stuff and hold additional values. And because they're all constants, everything is a constant. Therefore, everything will be reused, and you don't have like you're not holding this additional data. You're not holding the number 4 of this and that. You're not holding those inside of every instance that you're running. They're just all one reference. So that's nice. This resolves an issue of like, oh, you know what? I need to have a lookup table for this enum so that I can kind of correlate stuff. You can just define it in one place. And I presume it does strings. Can I like throw in, I don't know, final list of strings as let's say brands, right? Allowed brands of the thing. Looks like it can. Required this dot brands. And we would basically need to say for car, the allowed brands are what it would be, I don't know, Toyota or Ford. Whoa. And it needs to be const. Too many positional arguments. 0 expected by 1 found. Brands. There we go. So we can do that. For a bus will be some other brands and bicycle brands. And okay, so we can have a little bit more complex kinds of information. Awesome. This is very helpful. So using enums, access the enumerated value like any other static variable. Okay. Final favorite color is color blue, right? If favorite color is color blue, do stuff. Simple. Each value in an enum has an index getter, which returns the 0 base position of the value in the enum declaration. For example, the first value has index 0, second value has index 1, so red, green, blue, right? So in this case, I guess car is 0, 1, and 2, just like the way they're ordered there. To get a list of all enumerated values, okay, you can just call .index. So let's say I'll remove this stupid brand thing. We don't need it, we don't need it, we don't need it. There we go. So in theory, if I'm gonna say print Toyota.index, it will just give us the integer, right? Yeah, 0. There you go. If I would make it to be a bicycle, it should be 2. There we go. Okay, so that works. And to get a list of all the enumerated values, use the enum's values constant. Okay, and it will just give us a list of colors. So either can use those values or get an index from right each value, no problem. So that's awesome. That's a nice elegant solution. I like that. You can use enums in switch statements, and you'll get a warning if you don't handle all of the enums values. Okay, lovely. We have switch, and we need to do by case. So that's simple. If you need to access the name of an enumerated value, such as blue from color blue, use the .name property. Oh, we have .name. So we have dot. We either get the actual properties, right? Carbon footprint is two-wheeled. Oh, these are the getters. While here we have our fields. We get the index. We can get the hash code, random type, and name. And then we have just a bunch of comparison. Is to external reference to JS box, okay. JSify and no such method. And that's it. Okay, so yeah, just print me the name and we'll just say bicycle. Lovely. Can we do the other way around? To convert from string to the actual thing? You can access a member of an enum value like you would on a normal object. Okay. Okay, so there's no like string to the name. You would need to do that manually, but some lookup. Okay, I guess fair enough. And we can't. But what if we want to convert index into the value? Can we do that somehow? Can we do something like Toyota will be? I mean, I guess we could do values, right? And say, oh, the value of the index 1, right? That's how we would convert from index to the thing. But if we want to convert from a string to something, we can't really. We would just need to do values dot. And can we do something like first, right? And here we need to provide something. No, this is just first element. First where, there we go. First where, and we need to provide a function. So we're gonna value, right? And this is gonna be where return value is. What value dots? Oh, to string. What the hell is value supposed to be? Vehicle dot value. Have vehicle. Name. There we go. Is bus, right? Well, let's do bicycle. And this should create it properly. Hopefully. Yep, that worked. Okay, so not the best, but sure. I'm just surprised they didn't implement that. But okay. Oh well. It's a rare use case. Maybe they don't want to encourage that because the lookup and it's slow and whatever. Alright, so that's it for enums. Let's look at extension methods because I love extension methods. So let's see what capabilities do we have here. What can we call extension methods on? Can we add extension fields? Because that would be nice. That's what C# is adding. Extension fields, which is kind of absolutely awesome. But I don't think we'll have it here. Okay, extension methods add functionality to existing libraries. You might use extension methods without even knowing it. Yep. For example, when you use code completion in an IDE, it suggests extension methods alongside regular methods. If watching videos helps you learn, check out this overview of extension methods. We're not doing that. And test says no extension fields. Yep, I'm expecting no extension fields and probably no extension like getters and setters. So yeah, too bad. So we have overview. When you're using someone else's API or when you implement a library that's widely used, it's often impractical or impossible to change the API, but you might still want to add some functionality. For example, consider the following code that parses a string into an integer. Bam. It might be nice, shorter, and easier to use with tools to have that functionality be on string instead. Exactly. We do 42.parseInt. To enable that code, you can import a library that contains an extension of the string class. And so how do we do that? Import string APIs dart. Void that, and we have it, right? There we go. Extensions define not just methods, but also other members such as getters, setters, and operators. Okay. Operators. Oh, that's fun. I like that. Setters and getters. If we can do that, getters and setters, that means that we can pretty much fake adding a field. So that's all I want. So we have that functionality. There we go. Also, extensions can have names. I mean, yeah, of course they have names, which can be helpful if an API conflict arises. Okay. I guess we can rename them on the fly. Here's how you might implement the extension method parseInt using an extension named number parsing that operates on strings. So we have, okay, so we basically define extension number parsing on string, and we just say, okay, this is because it'll be on a string, so on any kind of string, we can call parseInt that doesn't take any arguments and returns an integer, right? And we have access to this. Okay, this is simple. So in here, instead of doing this, oh, vehicle values, whatever, I could probably specify extension. And the name of the extension is just number parsing. So let's do enum helpers, right? Enum helpers on enum. Okay. And what we're gonna do here is something that returns the, oh, can we do generic enum t? Wait, t on enum that returns t, and it will be from string. Guess we need to do lowercase here, from string, that takes a string input, so be whatever name, let's call it. And therefore, the way it's gonna do it is gonna we're gonna take and do it this way. So it'll be this as this enum. Oh no, it can't. The getter values isn't defined for the type enum. Oh no. Uh-oh. Is values like something else? Can I just do it on vehicle? Also doesn't have values. The static getter values can. Static getter. Oh. Enum dot values. What the heck? No. On string. No, I don't want to do on string. You're trying to define static function. Extension on string. No, I want to extension on an enum. And I want to take this dot, and I have index, hash codes. This will be actually just a value, right? So I need to do t dot values. And now it's complaining. The getter values isn't defined for the type. Oh, t extends enum? Oh no, I'm pushing it too far again. You don't have instance of enum. I mean, this is an instance of enum, right? But that's only like one thing. I would need to get the type that I'm calling it on, and get all of its values. That the getter values isn't defined for the type. So do I need to, oh. Can I turn T into dynamic? Final dynamic is whatever, it'll be the enum type is T. How about that? Enum type dot values first, where value name is name. Wait, what am I calling it on? Oh, because here on enum will be only called on an instance of an enum. I see. That makes sense. Yep, it doesn't make sense because I would need to call it on an enum type. So that would be a static extension, right? That's what I would need, a static extension. Is there a concept of static extension? Static types and dynamic. Oh, look at that. I already was peeking into that. Okay. All right, let's keep reading. Let's keep reading. Because, I mean, I can see now that I could probably do extension, enum, whatever, enum string helper, right? On string, if I will go from the string direction, I could probably do it, right? Because we have, I want to return, I need t extends enum, right? So we're gonna do, we want to return instance of t. So something to enum, we need to provide a t, right? And that's it. And that should basically be this. Oh, so it will be, again, I'm getting to the same point. Let's go here. Enum type value first, where value name is the same as this. And that's unhappy. The body might complete normally, causing null to be returned, but the return type t is potentially non-null value. Yeah, it should be this. And now it's unhappy because it has nullable return, but it ends without returning a value. So, oh, return, right? There we go. Will it magically work? That's the question. Can I say final Toyota is bicycle dot to enum, but I need to specify vehicle. I mean, it looks like it could work. And print Toyota.name. And now it's unhappy because name can be unconditionally accessed because, because we have this thing. So question mark. Will it work or will it crash? Error, class type has no instance getter values. So that values is probably magically made through something else. So that's probably the problem. The values is, who knows where it's coming from. Don't know. Let's see. Let's read more. So yeah, we did that. Extensions can define not just methods, but also other members. Yep. And we got that extension that implements that. The next section describes how to use extension methods. After that, after that are sections about implementing extension methods. Okay, so how to use them. Using extension methods. Like all Dart code, extension methods are in libraries. You've already seen how to use an extension method. Just import the library it's in and use it like an ordinary method, right? So import string API Dart, and we can just do pad left or parse in. Suddenly we have additional things existing on our string or whatever else we would define. That's all you usually need to know to use extension methods. As you write your code, you might also need to know how extension methods depend on static types as opposed to dynamic, and how to resolve API conflicts. Okay, so how they depend on static types as opposed to dynamic. Okay, by static types, they mean actual like integer, list, point, right? But dynamic is like different. So, I'm already assuming that with dynamic, there's some additional stuff to do to actually make the extension methods exist on them. So static types and dynamic. You can't invoke extension methods on a variable of type dynamic. I wonder if values is an extension method. For example, the following code results in a runtime exception. Dynamic D will be 2, right? The string 2. And that string parse end, runtime exception, no such method error. There we go. So that's what we're probably receiving in our code. Was it no such method? Has no instance getter. Okay, so that's what's happening. Oh, instance getter. So it tries to get instance getter rather than static getter. So that's very interesting. That tells us something that it's yet different. Extension methods do work with Dart's type inference. The following code is fine because the variable v is inferred to have type string. So, excuse me. Yeah, this was inferred correctly. The reason that dynamic doesn't work is that extension methods are resolved against the static type of the receiver. Because extension methods are resolved statically, they're as fast as calling a static function. For more information about static types and dynamics, see the Dart type system. Okay. And then we have the API conflicts. If an extension member conflicts with an interface or with another extension member, then you have a few options. One option is changing how you import the conflicting extension using show or hide to limit the exposed API. So import this also defines parseInt, but hiding number parsing2 hides that extension methods, right? So import this, hide this specific one, right? So we won't be able to use that extension methods in here. Another option is applying the extension explicitly, which results in code that looks as if the expression is a wrapper class. Okay, so we're doing like a, yeah, wow, okay, so we're taking the name of the class, we just say, hey, we're doing this kind of string, not that one. And that's it, okay? If both extensions have the same name, then you might need to import using a prefix. Okay, that's probably how I would like to do it. Oh no. Oh no. Okay, so if they are literally the same. Okay, makes sense. We would need to basically put a prefix in front of this one as well. As the example shows, you can invoke extension methods implicitly even if you import using a prefix. The only time you need to use a prefix is to avoid name conflicts when invoking an extension explicitly. Okay. Only string API 3 Dart has parse enum. Parse num. Okay, yeah, because that's a different thing. All right. So that's simple. So let's do implementing extension methods. Use the following syntax to create extension. Extension, the name, question mark possibly, on some kind of type. So extension name is optional. We don't even need to provide extension name. Oh yeah, because that's like just a name of a class, right? In theory, we don't need to do it. We just can define extension on something and then the actual members. Okay, and then we have can provide one or more members, right? So member definition, as in a number of them. For example, here's how you might implement an extension on string class. Extension number parsing, and we have parseInt, and we have parse double, and they're using this to refer to the instance of a string. Okay. The members of an extension can be methods, getters, setters, or operators. Extensions can also have static fields and static helper methods. Ooh. To access static members outside the extension declaration, invoke them through the declaration name like class variables and methods. So the members of an extension can be methods, getters, setters, or operators. Extensions can also have static fields and static helper methods. Okay, but these are not extensions at that point. To access static members outside of extension declaration, invoke them through the declaration name, just like before. Okay, so this is not like an extension on a static type or the instance. Okay, so that's the limitation. I see. And then we have unnamed extensions. When declaring an extension, you can omit the name. Unnamed extensions are visible only if the library where they're declared. Okay. Only in the library when they're declared. Okay, so if they're unnamed, we can't use them anywhere else. Only within that file, right? Extension on string. We can use it only within that file because if we were to import it somewhere else, suddenly we can resolve conflicts with it. And probably that's why. Okay, sure. You can invoke an unnamed extension static member only within the extension declaration. Okay, yeah, because there would be no way to get to it. Okay, implementing generic extensions. We already touched on that too. Jeez. First example that I'm going for is like trying Arctic edge cases. Why is it? Why is it that way? Every time. Extensions can have generic type parameters. For example, here's some code that extends the built-in list t type with a getter, an operator, and a method. There we go. So if we want to extend a list of an element t, right? So my fancy list t, whatever. And we're adding a getter, double length, which will be just length double. That's it. Okay. Where does it get the length from? It's just implicitly from the list, I presume. Okay. I see. We don't need to call this dot length. I like that. And then we have an operator of subtraction. So we reverse to list. Oh, that kind of operator. Oh, wait a moment. It's negative, right? So it's like negative list. How do you do subtraction then? Wouldn't I need to get another one? And then suddenly we have and suddenly we have the option of a situation of overloading. Is that true? We actually have overloading instance. That's hilarious. My fancy list, right? On a list. We have this. Doesn't mean I can do list t operator minus and do list, or I guess here object other. Looks like I can. And it'll be just return a new list, right? Look at that. We have overloading. Straight up overloading. Why can't we use it anywhere else? Come on. Bastards. Ah. The type T is bound based on the static type of the list that the methods are called on. All right. And more resources. Dart extension methods, fundamentals, feature specification, extension methods, sample. All right. I mean, it's nice. I like that we can define getters and setters. That's lovely. I know it's because these are two different operators, but we have the concept that we have something with the same name, right? And just different arguments. So in theory, it's overloading. I know it's two different operators. It's just, it's just funny that there is a concept of overloading of a name, but not anywhere else. Okay, so we finished extension methods. Now we can run over extension types, which is surprisingly long. So I'm gonna take a short bathroom break and I'll be back in a second. All right, I'm back. Tara says, I see. I remember myself looking into extension types. So let's learn about them. What are they? Because uh, is it related to extensions? What is it? An extension type is a compile time abstraction that wraps an existing type with a different, static-only interface. They are a major component of static JavaScript interop because they can easily modify an existing type's interface, crucial for any kind of interop, without incurring the cost of an actual wrapper. Oh, okay. So extension types enforce discipline on a set of operations, or an interface, available to objects of an underlying type, called the representation type. When defining the interface of an extension type, you can choose to reuse some members of the representation type, omit others, replace others, and add new functionality. Ooh. Okay, so the following example wraps the integer type to create an extension type that only allows operations that make sense for ID numbers. Oh, okay. So, yeah, I can see that. Extension type ID number, which extends the integer, right? Extends, yeah, sure. So wraps the int types arrow operator. So operator less than ID number other. ID is less than other ID. Doesn't declare the plus operator, for example, because addition does not make sense for ID numbers. Okay, so nim had something very similar because you could kind of extend existing types and then choose to make it unique or something. Where, they're in theory, they're both integers, like ID number, I guess in theory is still an integer, but a little bit more specific one, right? It's still a type of integer, but has stuff removed from it. Okay. And then in main, without the discipline of an extension type, integer exposes ID numbers to unsafe operations. And Tara says, with Dart, you can't count on similar. We'll see. I mean, I'm just saying that, okay, this concept sounds a little bit familiar. Yeah. I'm sure it's going to be different, but yeah. So integer, my unsafe ID is this thing, right? So this is unsafe, as in I can add 10 to it, right? This works, but shouldn't be allowed for IDs. So the otherwise, I can do safe ID, which is ID number this, right? Okay, so here we need to use it like a method we can do like with font prefixes or whatever, like a nim allows you to, but not a big deal. So it could be money or could be something else, right? And suddenly, oh, we can't add them. That doesn't make sense. Don't add integer. I mean, don't add some random integer to it. But my unsafe ID is save ID, right? Compile time error, wrong type. You can't set it to a normal integer either. Okay. But runtime cast allows us to cast it back into integer. Okay. So it literally just wrapped the type and we can cast. And we can probably cast the other way around as well. So save ID is less than ID number this. It's okay because you use wrapped operator. The wrapped operator allows us to compare only to other ID numbers. I wonder if we could actually override it to allow to compare to anything. So let's try that. Because this code here is, oh, we can do those, right? It just straight up already shows us we can't. Can I make it instead of ID number? Can I do object? It looks like I can. And it'll be ID less than other ID. So it needs to return Boolean. So is it less? I mean, it wouldn't make any sense, but in theory, I could. We don't have unions, so we can't do this or that. How could we make it that it also accepts integers and something else? Because that's what I'm used to do in various things. Like, oh, we can actually open it up and make it compatible with this or that. I guess we can't. Unless magically we can do operator on integer. Right? No, now it's like, oh, sorry. It's already defined. F you. Object. And let's make it just a normal thing. So if other is integer, right? We could probably get it over type, but whatever. I don't remember the switch operators right now. So if it's, let's say, if it's the number, ID number, right? We can just return this, no problem. Other.id. Return other as number ID. .id. No. The name number ID isn't a type. Oh, ID number. I mean, why do I have to do that? I already checked for it. What the hell? As whatever, I don't remember. Never mind. Otherwise, if other is integer, we could just do return our own ID, which is integer, is less than other as integer. And now it's unnecessary cast. It just told me that I can't do that. Unless it was just lack of, okay, so I can do that, okay. All right, so that's fine. Somehow it worked, didn't work the other place. Huh. Okay. And otherwise will be throw rock, right? So in theory, we could do that. And now it's like the argument type is ID number can be assigned to the parameter type of object. How? How is it not possible? It is an object. Can I do 1 to 3? 1 to 3 can be assigned to an object. ID number cannot be assigned to an object. Okay. Can I do extends object? No. Okay, let's keep learning about it because again, I'm trying to break it. Okay. All right. So that was simple. Extension types serve the same purpose as wrapper classes, but don't require the creation of an extra runtime object, which can get expensive when you need to wrap lots of objects because extension types are static only and compiled away at runtime. They are essentially zero cost. So why can't I assign it, if it's an integer, why can't I assign it to an object? Did I miss a square bracket? Square bracket. No, this just is unhappy because. Oh, wait a moment. You might be right. Okay, I have curly bracket, right? Curly bracket was missing, and it's still unhappy. Yep, it's still the same error. The number is fine. even though I'm comparing it. It's just for some reason integer fits as an object. ID number doesn't as object. I mean, I can kind of force it. Well, what's the point then? Will it run? I mean, it runs. No problem. Go figure. Extension methods, also known just as extensions, are static abstractions similar to extension types. However, an extension method adds functionality directly to every instance of its underlying type. Extension types are different. An extension type's interface only applies to expressions whose static type is that extension type. They are distinct from the interface of their underlying type by default. Okay? By default. So maybe there's something we can change there. Okay, syntax. Declaration. Define a new extension type with the extension type declaration and a name, followed by the representation type declaration in parentheses. Okay, so we're basically extending the integer. Okay. The representation type declaration specifies that the underlying type of extension type E is integer, and that the reference to the representation object is named I. The declaration also introduces an implicit getter for the representation object with the representation type as the return type. So int get I, right? That's why we were able to call ID on that thing. And an implicit constructor, bam, so that we can call E and provide it with that integer, right? The representation getter gives access to the representation object typed as the underlying type. The getter is in scope in the extension type body, and you can access it during its name, using its name like any other getter. Within the extension type body using I or this I. Outside with a property extraction, for example, e.I, where E is the extension type as its static type. Okay. Extension type declarations can also include type parameters, just like classes or extensions. Okay, so we can extend basically a list of T. Okay, that makes sense. Constructors. You can optionally declare constructors in the extension type's body. The representation declaration itself is an implicit constructor. So by default, takes the place of an unnamed constructor for the extension type. And additional non-redirecting generative constructors must initialize the representation object instance variable using the this.I in its initializer list or formal parameters. Okay, so basically we can define like named N and named M and whatnot. We just specify this or specify that the I is this, right? Great. And then we can use them. No big deal. Just like classes. Or you can name the representation declaration constructor, in which case there is room for an unnamed constructor in the body. So we can literally name that, like skip it, don't make it public. And there we go. We can just do that. We can call it what? Okay. Sure. I guess this is this as in whatever. So that the underscore belongs to this one, right? Another name. Okay. Sure. Let's move over, because so far it doesn't sound that helpful. You can also completely hide the constructor instead of just defining new one. Using the same private constructor syntax for classes, the underscore. For example, if you only want clients constructing E with a string, even though the underlying type is integer. So we have this hidden and E from string, give it a string and bam. Great. You can also declare forwarding you can also declare forwarding generative constructors or factory constructors, which can also forward to constructors of sub-extension types. Okay. Members, declare members in the body of an extension type to define its interface the same way you would for class members. Extension type members can be methods, getters, setters, or operators. Non-external instance variables and abstract members are allowed. Okay, that makes sense. This is good, right? We can basically add those extra things. But I understand that if we don't specify them, they just don't exist. So interface members of the representation type are not interface members of the extension type by default. Okay, so that's what it is. It's just like you do that, it's a blank slate. There's nothing defined other than a constructor by default. To make a single member of representation type available on the extension type, you must write a declaration for it in the extension type definition. Okay. You also can define new members unrelated to representation type, like iGetter and isValid method. Okay. All right. So you just need to do everything from scratch. Implements. You can optionally use the implements clause to introduce a subtype relationship on an extension type and add the members of the representation object to the extension type interface. Okay, so let's see, because this is something I would like, hey, just reuse the existing thing. The implements clause introduces an applicability relationship, like the one between the extension methods and its own type. Members that are applicable to the supertype are applicable to the subtype as well, unless the subtype has a declaration with the same member name. Let's just see an example. An extension type can only implement its representation type, for example. This makes all members of the representation type implicitly available to the extension type. So we have extension type number I, right, implements int. And okay, so we didn't open the bracket here, we just threw this in here. So number I can invoke all members of integer. Beautiful. So we're suddenly like extending the integer. Plus anything else it declares here. Okay. A supertype of its representation type. This makes the member of the supertype available, while not necessarily all the members of the representation type. So we have a sequence of T. Excuse me. And we created by providing a list, right? So it's backed by a list, implements iterable T. So a better operations than list, right? So it provides those on this somehow. Okay, so extension type ID integer implements object, makes the extension type non-nullable. Select ID, try parse, string source, and try parse source as ID. Okay, sure. I'm not gonna go deep into that. And another extension type that is valid on the same representation type. This allows you to reuse operations across multiple extension types similar to multiple inheritance. Oof, this is gonna be getting crazy. So extension type constant option T is defined on annullable. What the hell is that? A map? T value? No, what the hell is it? I don't even know what this means. Wait a moment. Nullable with this just parentheses, so that suggests that it's a either if wait, what? Don't even know what that means. and we have this and that. And then we have, excuse me, value t. So it's a record type. Okay, so it is a record type. With a named field. Oh, that's what it is. Named field in a record type. I forgot a record type can have named fields. Okay. All right, thank you. That's an option T. So basically we can have a record. It's an optional, right? With the value inside of it. All right. And then, great. So we define that. And we can have either specify constructor for none or T. Okay, so we're getting into this the nice functional stuff. All right. Extension type, constant value, and then none. Beautiful. All right. So we have the good example here. It's just hard to read. Value of T, which is again holds the value, but it's non-nullable, implements this one. Therefore, it provides that to some extent or not. Value T, I don't know how this does. I guess I can just fit it in there. I guess that's all it does, that I can fit this within that. And then we have the non. Oh, this one uses those. Okay. None, which will be always a null value, right? Implements option never. So again, keyword never that we haven't seen before. And that's it. Okay, so this is your classic, whatever, option type, right? I forgot there was like M word for those. Like a series of those, whatever. Read the usage section to learn more about the effects of implements on different scenarios. It's good that we can use that. And then we have redeclare. Declaring an extension type member that shares a name with a member of a supertype is not an override relationship like it's between classes, but rather a redeclaration. I think I'm gonna start skipping this stuff because I'm not gonna use that anytime soon. This is like advanced feature. Never is a type you can't really have anywhere. Okay. Yep. We just know that it's gonna be an option of that's never gonna be used, right? Great. So sometimes never is used. Never always throws. Okay. All right. So we've got usage, and I'm just gonna start skipping, provide extended interface. So this is where we're gonna start mixing it in with other stuff, right? Different interface, existing type, type considerations, extension types are compile time wrapping constructs. At runtime, there is absolutely no trace of the extension type. Any type query or similar runtime operations work on the representation type. This makes extension types an unsafe abstraction because you can always find out the representation type, at runtime and access the underlying object. Okay, dynamic type tests. Let's just skip that. This is like waste of my brain right now. When I will get comfortable with the type system, then I can start thinking about those. All right, so let's go to callable objects. That's gonna be very, very, very short because it's a very simple thing. To allow an instance of your Dart class to be called like a function, implement the call method. And that's it. The call method allows an instance of any class that defines it to emulate a function. This method supports the same functionality as normal functions, such as parameters and return types. In the following example, the wannabe function class defines a call function that takes 3 strings and concatenates them, separating each with a space and appending an exclamation. Yep, so we have a class that just has a call method that returns a string and takes some strings, right? And just bam. And we can therefore call it without any parameters, so it looks like a constructor. Uh, Therefore, I guess we can't have the default constructor here. And that's it. And they don't say that it's anything. And Tara says, should this have been an operator instead? What are you referring to? Because I'm not sure for the call. So how does it work with... Can I do some... Let's see what happens. So I have this wannabe function, right, with a call. Can I define also at the same time wannabe function? Oh, I can. This doesn't cause any issues. Oh, because this takes stuff, right? I would need to do string A, string B, and string C. Okay. And it doesn't do anything with them. It's just gonna say print this, okay? And that's it. So which one is going to get called now? 3 positional arguments expected by wannabe function dot new but 0 found. Oh wait, because I can call it only on an instance. Oh, of course. So I can do A, B, C. And now I have the instance and I can call it on an instance. Oh, that's the thing. I totally missed the point. It's completely separate from a constructor. Therefore, constructor is static. This is instance wise. So that's fine. This will run. I'm going to have ABC and hide again. Okay, cool. That sounds right. And because we cannot call static functions on an instance, that makes sense. And Tara says, yeah, call function could have been an operator. I mean, it could be, yeah. It's just what would represent it? Bunch of parentheses? That would be probably confusing. So they just figured it's gonna be a function, but that means can I do dot call? Yeah, you can do call. Okay. All right. It's one and the same thing. Okay. They played it safe. This feels like they really needed that feature for something, and they just threw that in. For some API, you know what? It would be fun. We could do that. It would simplify it. And okay, we're gonna implement that. Okay, so calm before operators will implement it, possibly. I have no knowledge of history. All right. I mean, right now I want to... how difficult would that be? Community. Is there like a repo for... Is this an open source project? Dart. What the hell? Why didn't it open like a weird thing? What? Open the entire page. What the heck's going on? Here. That was weird. So we have this Dart. I mean, we have README here. We have design of the language, which is just TEX, which is... What the hell is TEX? Template specification, resources, doc, archive, accepted, newsletter, markdown files. Okay, so this is just like specification. We have web, www, this. the SDK, the Dart SDK, including the VM, JS, and WASM compilers, analysis, core libraries, and more. So this is it. So that means that I can copy this. I can go to new page, right? Let's go to repos, right? And git clone this, right? Oh, wow, that is a big repo. Come on, you can do it. Okay, while this is happening, I'm gonna go back to my documentation and what else do we need to do? So we finished the classes, your class modifiers. So this is short-ish. We need to go through that before we can go into concurrency. So I'm gonna give it a read to have basic understanding. And this thing here is done. So SDK. Okay. So we're in here. We have a bunch of stuff. So I'm gonna do something weird. We're gonna try to dangerously skip permissions, okay? Okay, we're in Claude. It can do whatever it wants. And let's just do let's just explore with focus on language itself and how the what is functions / methods are being called / implemented. Okay, we're gonna let it run, explore some stuff. All right, in the meantime, get back to the documentation. I'll hear like an announcement when it finishes. All right. So class modifiers. So wow, this is relatively new feature. Interesting. Class modifiers, besides abstract, require language version of at least 3. So they recently complicated everything, right? So class modifiers control how a class or mixin can be used, both from within its own library and from outside the library where it's defined. Okay. Modifier keywords come before a class or mixin declaration. For example, writing abstract class defines an abstract class. Duh. The full set of modifiers can appear before a class declaration. That can appear before class declaration include abstract, base, final, interface, sealed, and mixin. So far we learned a little bit of abstract, a little bit about interface, and a lot about mixin. And that's it. Only the base modifier can appear before mixin declaration. Okay, so mixin cannot be abstract, cannot be final, interface, sealed. It can be only base. Okay, good to know. The modifiers do not apply to other declarations like enum, type definition, extension, or extension type. Okay. All right, so only mixins and classes. When deciding whether to use class modifiers, consider the intended uses of the class and what behaviors the class needs to be able to rely on. Okay. Tip: if you're already familiar with Dart's class modifiers and just want to outline a refresher, if you ever combine, check out the class modifier reference. Great. We don't maintain any library. All right. So no modifier. To allow unrestricted permission to construct or subtype from any library, use class or mixin declaration without a modifier. Okay, so basically no restrictions, right? By default, you can construct new instances of a class, extend class to create new subtype, implement a class or mix an interface, or mix in a mixin or mixin class. Okay. All right. So we have tear offs, we have mix ins. So abstract. So to define a class that doesn't require a full concrete implementation of its entire interface, use the abstract modifier. Okay. Abstract classes cannot be constructed from any library, whether its own or an outside library. Yeah, because they don't have a full concrete implementation, therefore they cannot be. Abstract classes often have abstract methods. Yep. Like, we have abstract class, and therefore it doesn't define something in a concrete way. All right. And an RB Dart error can be constructed. Yeah, we can't construct vehicle because it doesn't have full implementation, and therefore is marked as abstract. I mean, if we gave it implementation, right? Even though it's fully that concrete implemented, we still wouldn't be able to create it because it's just marked as abstract. Okay. So the abstract basically suggests that, okay, this class is allowed to have not concrete implementation. But it can be extended, right? Class car extends vehicle, and therefore we are forced to implement it. That makes sense. Nothing crazy here. And it can be implemented because just like an interface doesn't have to have all the implementation. Let me just check on Claude. It's still spelunking. All right. Okay, it's gonna write us the
finished.
Oh, just finished. Let's learn something. Summary. This is the Dart SDK repository, the complete implementation of the Dart programming language, its runtime compilers, core libraries, and development tools. So product structure. Language implementation. Complete the implementation, including the VM compilers to JavaScript, WASM, and whatever DDC is. Analyzer and its core libraries. Multi-target supports native, bunch of architectures, comprehensive access system, over 80 packages in the package. Okay, so this also includes the main packages. All right, all in one repo. Function, method calling, patterns, and implementation. Core VM implementation, method dispatch, sophisticated megamorphic cache system for polymorphic method dispatch with hash-based lookups. Don't understand what it means. Stub code, architecture-specific assembly stubs for optimized calling conventions, dynamic resolution, extension methods, static resolution, and compile time with no runtime overhead. There we go. It matches the documentation. Calling patterns, native bridge, async away, generic methods, and error handling. Okay, unique features. We have method recognizer, compiler intrinsic for performance critical operations using fingerprint-based identification. What the heck? Closure optimization. Okay, and dispatch tables. We have design patterns. Let's just skip reading that. So what specific Dart language features are you most interested in exploring deeper? Are you looking? Let's ignore its questions. This is just part of my template. Let's just tell it something crazy. I need you to dive deeper into how the methods are matched, selected when called. The Dart language is missing. Let's actually put it into plan mode only, okay? Dart language is missing the one crucial feature. Function overloading. I literally can't live without it. I need you to go deep into the code and figure out how to add this feature. I need to be able to overload functions and methods, including let's not go include methods. Let's keep it simple. Functions and methods. What it means is that multiples of the same function name. Functions need to differ either by return type or arguments, argument types, count, etc. Same as in C#. Okay, we're gonna give it that way. All right, and the compiler should figure it out on its own. Okay, so I know that operators like minus kind of implement that already, as you can have operator minus and operator minus other. Okay. So we'll say prepare overall plan on what and where needs to change. This is like a massive project. Let's see what it's gonna come up with. Oh, this is hilarious. Okay, so let's get back to that. We know what abstract does, right? If you want your abstract class to appear to be instantiable, define a factory constructor. Okay, if you want abstract class to be instantiable, define a factory constructor. So I can define a factory constructor on an abstract class, and suddenly that makes it instantiable. Weird, but okay. Why? Okay, base. I mean, I can imagine this happening in a way that some subclasses that implement the abstract method somehow statically register themselves in something that the abstract class can access, and therefore the factory can figure out how to instantiate subclasses. No, weird. What the hell? Okay, base class. I mean base, whatever. To enforce inheritance of a class or make sense implementation, use the base modifier. A base class disallows implementation outside of its own library. This allows implementation. What do you mean by the word implementation? To enforce inheritance of a class or make sense implementation. Inheritance of implementation. Use the base. A base class disallows implementation outside of its own library. So we have abstract base class. We cannot implement it outside. What the hell? This guarantees the base class constructor is called whenever an instance of a subtype of the class is created. All implemented private members exist in subtypes. All implemented private members exist in subtypes. A new implemented member in a base class does not break subtypes, since all subtypes inherit the new member. So this is true unless the subtype already declares a member with the same name, blah, blah, blah. Okay, so you must mark any class which implements the extended base class as base, final, or sealed. Okay. This prevents outside libraries from breaking the base class. So we have the vehicle, base class vehicle, right? Move forward. And it has some implementation. So then we have the bdart. I mean, the other file, right? So we can construct the vehicle because it's not an abstract class. We can extend it. So base class car extends vehicle, but cannot be all implemented as an interface. So basically we're saying that, oh, so it's a base class, therefore it's supposed to be used as a class and not an interface. Okay, so just basically say, hey, don't use it as an interface outside of this very file. That's it. This is a wacky explanation. What the hell? And of course, whatever is extending it needs to work in the same way, right? And because we cannot use it as an interface, that means because if we were to use the class as an interface, that means it forces us to provide implementation of everything from that interface, whatever that interface class, whatever, from scratch. And because of this, we can do it. We can only override it explicitly, I presume, right? So let's say, I mean, whatever, right? Because it says a new implement member in a base class does not break subtypes since all subtypes inherit the new member, right? So if we added some, we already have a hierarchy, we just decided, you know what, we're going to add another method into the base class. We are guaranteed that everything that uses the base class, because it's only used as actual class, not interface, they all have that, right? And this is true unless the subtype already declares a member with the same name and an incompatible signature. So basically, if we override it, right? And an incompatible signature. What if we have the same signature? That means we can't override with the same signature? Oh, maybe we can't override at all. And Claude did some, wow, whoa, what the heck? It just gives us a bunch of stuff. What needs to happen? What is the plan it proposed? Where does it begin? Okay, here's the comprehensive plan. Comprehensive analysis, method signatures, and function overloading in Dart SDK. Current method signature handling. We have this thing, VM layer, function call structure, key limitations, and overloading, single signature storage. Each function object stores exactly one function type signature. Okay. Name-based lookup uses only the function name, not signature. No signature comparison. No infrastructure exists to compare, differentiate signatures for the same name. Okay. We have the analyzer layer. Oh, great. Function type implementation represents function signatures with this, and that. Method resolution. Oh, geez. Element model. Implementation plan for C# style function overloading. There we go. Phase 1. Core infrastructure changes. The VM layer modifications. Runtime VM. We need to change the object model to, I guess, have stuff and be able to resolve. Extend class to support overload sets. Algorithm for resolution, analyzer infrastructure, new overload management, and all this stuff. Okay, sounds simple, right? Type system integration, method resolution updates, inheritance system, language specification changes, grammar extension, resolution rules, front-end parser integration, error handling, testing validation, migration path, ensure backwards compatibility. Great. Challenge 1, performance impact. We don't care about performance. Type inference complexity. Great. Existing code. This comprehensive plan addresses the fundamental limitations in Dart's current architecture and provides a roadmap for implementing C# style. Okay, so let's do yes and auto accept edits, right? We're gonna let it run, but I'm gonna stop in a second. I'm gonna stop it here, right? We'll interrupt it. So we're gonna do something funny. Please transform your plan into a board compatible for each task of the plan represents a phase of your plan. Make sure that each of those phase steps of the plan submitted to the board contains a full description of what needs to happen, which is suggested sub steps. What is it? Related code, extra context. Prepare the plan and submit to the board, ensuring all steps are marked as needing breakdown. Let's see what happens. Let's just see what happens. I know that I will need to log into the board. Let's see if I'm already here. Which account is it? Might be this. Okay, I'll show it later. Okay, while this is thinking, we learn a little bit about the thing. But I wanted to do something, yeah, with the base class. I wanted to basically see that what if I'm going to create like a new file here, right? Base, whatever, v equal dot dart. I'm gonna paste this here, right? Base class vehicle. We have move forward will be just print. I'm moving forward by some meters, right? That's all that we need. And then here, I want to have my subclass, right? So we're gonna, where's our main is here. Wow, okay. We probably need to import what is it? Package vehicle? How the hell did it work? Can we do like import here? Just play on different superclass, removing the extents. Import a.dart. Yeah. Vehicle.dart. It doesn't, oh, now it allows me to, okay, great. So we have this, right? And therefore we can just do something simple here with main. What is Claude doing? Okay, it created a plan. Do you want to proceed? Yes. Okay, I got the plan ID, so I'll be able to, I'll open it up on my end.
Plot finished.
If I can only copy that ID. I mean, I have it here. Okay. Let's copy. Let's paste it here. I can probably show that in here. Let's literally plop it here. And does the plan look okay? Looks like it looks okay, right? Implement this and we have some very short but stuff. Okay. So please, and let's do it by passing, please proceed with the plan execution. Okay. And now it's gonna just keep going and breaking up stuff, right? So that's wonderful. As it's going, we're gonna continue experimenting. So here I can just say, you know, new class vehicle, right? So final car is just car, right? Do I need to provide 4 or something? No, just car. Passengers are our default 4, so we can do car dot move forward by how many meters? 5 meters. We save it, we run it. I'm moving forward by 5. So now the question is, can I provide exactly the same but my own? I'm driving forward by meters, right? So I've overridden it with exactly same compatible signature. What's going to happen? I'm driving forward, so we can override it. Okay, can I do override keyword? It doesn't complain. Can I change it to not have this? I cannot. So can move car move forward isn't valid override of vehicle move forward. Okay, so I can only override it. Okay, makes sense. And Claude create this, do that. Okay, so this is gonna be good enough. We'll let it run and we'll see if we're gonna magically get new features in the language. Which would be hilarious. Okay, so we know about base class. It just makes it that, hey, this is not an interface. It needs to be class only. That's fine. So now we have the interface keyword, which is confusing. To define an interface, use the interface modifier. Libraries outside of the interface to define an interface. So it says to define an interface, huh? Libraries outside of the interface's own defining library can implement the interface but not extend it. And this guarantees that when one of the class's instance methods calls another instance method on this, it will always invoke a known implementation of the method from the same library. So when one of the class's instance methods, so we have a class, which class? Instance methods calls another instance method on this. It will always invoke a known implementation of the method from the same library. So we can implement it, we cannot extend it. Oh, they mean that if I have a class that will implement the interface, right? It will always, whenever it refers to this, it will run something that's implemented within only the hierarchy of this class, not the interfaces, right? Because we cannot extend it, right? Because we absolutely cannot extend the interface class. That means that we cannot use it as a class. We can only use it as an interface. So that makes sense. It's just we're suddenly losing the idea of, oh, interface can extend another interface, right? But here we can just implement interface on another interface so it still works. Okay, that makes sense to me to some extent. So one of the we went through that. Other libraries can't override methods that the interface class's own methods might later call in unexpected ways. This reduces the fragile base class problem. Okay, so there is some fragile base class problem. Okay, so we have interface class vehicle, right? It can be only used as an interface, not as a class in that case, right? It's just the throwing the class in there for no reason. So move forward some meters, right? So it can be constructed. Vehicle, my vehicle is a vehicle. Okay, because it's not abstract. Okay, so because it's not an abstract interface class, we can actually construct it. All right. But it cannot be inherited. Okay? We can't just extend it. But we can implement it. Okay, so that makes sense, right? And then therefore next we have the abstract interface, which is even closer to the real thing because we won't be able to construct it. We will be still able to only like implement it, right? The most common use of an interface modifier is to define a pure interface. Combine the interface and abstract modifiers for an abstract interface class. Like an interface class, other libraries can implement but can't inherit a pure interface. Like an abstract class, a pure interface can have abstract members. Okay, that makes sense. And therefore, because it's abstract, we won't be able to construct it. Yep. Okay, that makes sense. All right, it's not too bad, not too bad. Kind of weird because we had a class thrown in there, but oh well. So the moment we see the word interface, we cannot use it as a normal class, as in we cannot extend it. The moment we have it as a base, we cannot use implement, so we cannot use it as an interface. And that's pretty much it. Okay. And then we've got a final. To close the type hierarchy, use the final modifier. This prevents subtyping from a class outside of the current library. Okay? Disallowing both interface and implementation prevents subtyping entirely. Disallowing both inheritance and implementation. Okay, so no extends and no implements. Yeah, we can't subtype anymore. Only outside of the current library, okay? So within the library, you can still do hierarchy or whatever, right? But not outside of the library. Great. So this guarantees that you can safely add incremental changes to the API, right? Because nothing's going to extend it, nothing's going to override anything. And you can call instant methods knowing that they haven't been overridden in a third-party subclass, right? It's like a finalized thing. Nobody can modify it. Final classes can be extended or implemented within the same library. Okay, the final modifier encompasses the effect of base. And therefore, any subclasses must also be marked as base, final, or sealed. Yep, it makes sense. So basically, we can think like, even though we can kind of extend them within the same library, within the same file, so we can kind of make like 3 levels of something where they inherit from each other, but they cannot be modified outside, right? We cannot extend or something in further, which I see as fine, right? We have a final class vehicle and, we can construct it, right? It's not abstract, so it has the implementation. And it can be inherited, right? Because sorry, you can extend, you cannot implement, right? And that's it. You can just construct it. That's all you can do. All you can do is actually use it. So that makes sense. All right. And I can see that it would be possible to make a abstract final, huh? Okay, so then we have sealed. To create a known enumerable set of subtypes, use a sealed modifier. Enumerable set of subtypes. And no, use the sealed modifier. This allows you to create a switch over those subtypes that is statically ensured to be exhaustive. So the sealed modifier prevents a class from being extended or implemented outside of its own library. Sealed classes are implicitly abstract. So they cannot be constructed themselves. They can have factory constructors. What the heck? Why? They can define constructors from their subclasses to use. They can define constructors for their... Oh, right, because we can still subclass them from within the file. Therefore, the factory constructors very remotely, but it kind of makes sense. But that's pretty much it. Huh. Very, very, very strange.
Plot finished.
And sorry, I got distracted. And Claude finished for some reason. What the hell? Where did it finish? Refresh. It stopped here. Oh, it might have compressed something. I need to shorten the progress report. I've successfully completed class object. The core VM runtime is now ready. Do you have correct plan ID for me to report to the board or... Oh, see, the plan ID got all wonky. I guess we got the context shortened. It just ran out of context already? That would be fast. Plan details, sure. Here's the correct plan ID for the board. Please report the progress and continue cooperating with the board. Oh, I need to capitalize D and B. Love doing that. Okay, it should manage now. Hopefully, right? Copy the same thing, submits, perfect, and it continues on. All right, great. Okay, so subclasses of sealed classes are, however, not implicitly... Oh, subclasses of sealed classes, okay, are, however, not implicitly abstract, but they will have to still continue to be final or something, right? Or maybe not. So the compiler is aware of any possible direct subtypes because they can only exist in the same library. All right? This allows the compiler to alert you when a switch does not exhaustively handle all possible subtypes in its classes. So we have sealed class vehicle, right? It's totally abstract. Therefore, we'll be able to iterate over all possible vehicle types. So we have class vehicle extends vehicle. Okay, so it can be normal class. It extends the vehicle. Truck extends vehicle and bicycle extends vehicle. So we cannot instantiate it because it's abstract, just implicitly. Subclasses can be instantiated, right? So I can make an instance of a car and then string get vehicle sound. So we get a vehicle and error, the switch is missing the bicycle subtype or default case. So basically, if we're gonna do switch by vehicle, we can check car, truck, or a bicycle. But I want to check this example further because notice that these are just class truck, right? We can subclass from them somewhere else. But I guess I will have only those options from within here, like a little snapshot or something. So let's go to our vehicle and here we have vehicle, car, truck, bicycle, right? Nothing else. We just have those three. And here, let's just do it something here, right? We can instantiate it. That makes sense. Subclasses can be instantiated. So let's actually move that to our main function, right? Somewhere here. Okay, subclasses can be instantiated. Right, I've got my car, so that's great. Get vehicle car sound. We just need to make sure that we also have the bicycle, right? If it's bicycle type, then I don't know what bicycle sounds. What sounds make bicycles make? Um, ring, ding, eling. I don't know that's the sounds bike make. Sure, ring, ding, eling. That's the bicycle sound. So that's okay, right? The declaration of get vehicle sound is in reference, so we can just get vehicle sound, and we do provide in my car, right? And that should work. We run it, and we get nothing. Oh, print. So we should get a car sound, which will be room. There we go. We got a room, so that worked. But what happens? Can I go, because notice that the car is just normal class. It extends the sealed class, but it isn't sealed itself. So can I do something like class supercar extends car? I can, but that won't let me do supercar here, or will? Something? But it says this case is covered by the previous cases, right? So I could, in theory, just throw it in here. It's fine. But that means that if I don't have it, I mean, in theory, this case is covered, right? Oh, that's what I ensure, that even though I'll provide a supercar, I will cover this. I won't get it as an option that's required, but I will cover it. Okay. And if I, for some chance, would move it in here, because this doesn't extend directly from the vehicle, it will still not be required. Okay, all right. That makes tons of sense. We just want to be able to cover all the, like, at that level, everything. And that's it. It's just very weird name to have it sealed. But, I mean, it makes it that I can't extend it from outside the file, so it's all in here. So, okay, sealed kind of makes sense, kind of doesn't. And this is still doing stuff, right? Okay. I'll let it go, and Magic will have the core VM runtime infrastructure for function overloading. Oh, this is hilarious. Okay. Okay. So that's that. It all makes sense. It's not too bad. If you don't want exhaustive switching or want to be able to add subtypes later without breaking the API, use the final modifier. For a more in-depth comparison, read sealed versus final. So you want to be able to add subtypes later without breaking the API. Use the final modifier. But with final, everything else needs to be final as well. Therefore, and that final needs to be within the class. It cannot be outside of it. So suddenly I'm losing the ability of doing sealed. Yeah. Because sealed, I was able to, so I will just need to use base. And that will be it. I can extend it from somewhere else. Oh, wait, but sealed doesn't, oh, so there, okay, some cases are not covered. So combining modifiers. You can combine some modifiers for later restrictions. A class declaration can be in order. Abstract is optional. One of base, interface, final, or sealed. Okay. Or optionally mixin or class. You can't combine some modifiers because they are contradictory, redundant, or otherwise mutually exclusive. So abstract with sealed, not really, because sealed is already abstract. Interface, final, sealed, or mixin. These access modifiers prevent mixing in. Okay. And for further guidance, so let's look at the class modifiers API. Maintainers know the reference. There we go. Okay, so as a quick review, just class allows us to construct, extend, implement, but not mix in, and is not exhaustive. I guess exhaustive is for the sealed, right? Sealed is the only one that is exhaustive. Okay. Base class still allows us to construct and extend, but not implement. Okay. Interface class allows us to construct and implement, but not extend. Okay. That's simple. So basically, when we have base, can only extend it. It acts only as a class. If we'll throw in interface, it will act only as an interface, not as a class. Kind of, because you can still instantiate it, right? Oh, they didn't put in. Can you instantiate it? It's missing a column. Come on. Yeah. Oh, construct. Yeah, that's what it is. So interface class you can construct, but abstract interface class should be everything except construct. So see, yes, no. We cannot construct anymore. We weren't able to extend, we still are not able to. We were able to implement, and we still able to. Okay. Then we've got the final class, which means we can still construct it, but we cannot extend it nor implement it. It's final. And that's it. Sealed class means that we cannot construct it because it's abstract. We cannot extend it nor implement. We cannot extend? Oh, we cannot extend directly, right? We can extend the subtypes, yeah. It just doesn't propagate up there. And it's exhaustive, right? Abstract class, so it still acts both as a class and a interface. It's just we cannot implement it because it's not guaranteed to have concrete implementation. Abstract base class, so it's just like a base class, as in we can extend it, but not implement it because it's not an interface. And it doesn't guarantee to have concrete implementation. Abstract interface is just the same thing instead of here it's here. An abstract final class. We can't do anything with it. You can't construct it. You can't extend it. You can't implement it. Nothing. But you can extend or implement within the same tree, within the same file, right? So in theory, you could implement final non-abstract classes, okay? That makes sense. So then we have mixin class. So all it is, we're just throwing a mixin. Base mixin class. Yep. Abstract mixin class. Great. Abstract base mixin class. Okay. All right. But notice that we don't do interface with mixin because they don't mix, right? And just mixin, it's just mixin. It allows us to implement, but doesn't perform as a class. Okay. And lastly, we have the base mixin, which we can mix it in, but we cannot implement it nor extend. I guess it's just purely mix in, right? That's all it is. Okay, so because it doesn't have the class word, so base means purely a mix in. Okay, and about the combinations, like and do we have interface and mix in? Mixing an interface or final or sealed, right? A mixin or mixin class declarations is intended to be mixed in, which is the listed modifiers prevent. Yep. Okay. So last topic for today is just concurrency. All right. This should go fast because I think it's a short topic and pretty familiar. This is already going further. That's great. Okay. So concurrency in Dart. This page contains a conceptual overview of how concurrent programming works in Dart. It explains the event loop, async language features, and isolates from high level. For more practical code examples of using concurrency in Dart, read the asynchronous programming page and isolates page. Okay. We'll read the asynchronous. I don't think we'll be going into isolates because I believe it's a little bit more advanced feature of actual multi-threading. We won't be doing that in our little upcoming API. So concurrent programming in Dart refers to both asynchronous API, like the future, which is like equivalent of, for example, promise in JavaScript, or a task in C#, and stream. Okay, feature and stream. Stream is just a synchronous enumerator, right? Or enumerable. And isolates, which allow you to move processes to separate cores. Exactly. So these are the real threads. These are not threads. These are just pauses. While I'm waiting for something, you can execute other code, right? All Dart code runs in isolates, starting in a default main isolate. What do we call isolate? It's a thread, unless there's some reason for it. And optionally expanding to whatever subsequent isolates you explicitly create. When you spawn a new isolate, it has its own isolated memory and its own event loop. The event loop is what makes asynchronous and concurrent programming possible in Dart. Okay, so because isolate has its own memory, so they're probably suggesting like, okay, we're gonna not call them threads because threads kind of have shared memory, while isolates just can't. So I guess that's the reason here. Okay, so the event loop is what makes asynchronous and concurrent programming possible in Dart. Notice concurrent, not parallel when it comes to event loop. All right, event loop. Dart's runtime model is based on an event loop. The event loop is responsible for executing your program's code, collecting and processing events, and more. So something tells me this is exactly equivalent of what JavaScript has, and that's why you have the good interrupt between JavaScript. This guy's still chugging. Yep. Wow, that's a long list. All right, as your application runs, all events are added to a queue called the event queue. Events can be anything from requests to repaint the UI to user tabs and keystrokes to I/O from the disk. Because your app can't predict what order events will happen, the event loop processes events in the order they're queued, one at a time, right? So we have the event queue. Events come in like repaint, process tab, repaint, and because it's a queue, they just line up, and first one that came in will be first one executed. The way the event loop functions resembles this code. While event queue, wait for event, just process next event, right? No priority, right? This example event loop is synchronous and runs on a single thread. However, most Dart applications need to do more than one thing at a time. For example, a client application might need to execute an HTTP request while also listening for a user to tap a button. To handle this, Dart offers many async APIs like features, streams, and async await. These APIs are built around this event loop. For example, consider making a network request. So HTTP GET, we just call HTTP GET, and this looks exactly JavaScript, right? Then we take in the response and run this function. So we have the callback function, right? If response is status code, print success, that's it. Exactly like JavaScript. When this code reaches the event loop, it immediately calls the first clause, HTTP GET. So when this code reaches the event loop, okay, whatever that means, it immediately calls the first clause, HTTP GET, and returns a future. Oh yeah, because the GET returns a future, right? I promise, whatever. It also tells the event loop to hold on to the callback in the then clause until the HTTP request resolves. Because notice that .then is being called on the future returned from the get, right? So we have literally future .then. So we have a reference to it and we're just calling it on that. It also tells the event loop to hold on to the callback in the then clause until the HTTP request resolves. When that happens, it should execute that callback, passing it the results of the request as an argument, right? So we have the event queue, HTTP requests, do stuff, repaint requests, repaint whatever. So when it goes through HTTP request, it's a future, it executes it, and then on HTTP response callback, do stuff, whatever, right? Sometime later, we actually got the response that I guess was lined up in a queue as well. So after maybe the repaint request happened and something else and some other keystroke event, whatever, it got here. And we can actually call the response handler, whatever, on response callback, right? Simple enough. This same model is generally how the event loop handles all other asynchronous events in Dart, such as stream objects. So asynchronous programming. This section summarizes the different types and syntaxes of asynchronous programming in Dart. If you're already familiar with future, stream, and async await, then you can skip ahead to the isolate sections. So let's just have a quick overview. It should be really fast. Futures. A future represents the result of an asynchronous operation that will eventually complete with a value or an error. So it's exactly like a task in C# or a promise in JavaScript. I mean, a little bit closer to promise because the tasks in C# can run on other threads, but just that. In this sample code, the return type of future string represents a promise to eventually provide a string value or an error, right? So we have a function read file async that will return a string, possibly in the future, right? And takes a string. So we have our file, right? And return file read as string. So this will be probably read as string. We'll return a future on which we're going to run then something which returns the same future, right? So we return a future and that's it. That will eventually return the contents trim. So we kind of created two futures, right? Yeah, we created this future and with that future and return a bunch of them. So the async await syntax. The async awaits keywords provide a declarative way to define asynchronous functions and use their results. Okay, so here's an example of some synchronous code that blocks while waiting for file I/O. So we have our string file name, right? We have our main function, read some data, and then we have final file data is read file async. Okay, so that might be read file sync. So this is asynchronous. It's just gonna block. And I have JSON decode, which is, I guess, also sync, and then use that data. So let's look at our read file sync. Final file, we get our file, we do file contents is file read as string sync. Everything's synchronous. All right, so why am I reading it? This is all synchronous. Here's similar code, but with changes. Highlighted to make it asynchronous, right? So we marked our main as async, and we're marking it after the name. Okay, good to know. And C# and JavaScript will do it ahead of time. So read some data, right? The file data will be, we're gonna await for whatever this returns. So that suggests that it could be async, but something tells me as long as it returns a feature, it's fine. The async keyword, all it allows us to do is use await keyword in here, and that's pretty much it. So it enforces it to return a future, implicitly in this case. Yeah, as in we don't have to specify future of something, it wraps it automatically. And then we have our JSON decode. For some reason, no need to await for that here, and use the data. So, bam. So then we have our read file async, right? We specify that it's a future of a string. Oh, so even though we have async keyword, we still need to specify that this is a future. All right. And we do stuff and we are awaiting the read as async. Okay. And that's it. So basically, instead of doing this, file, then do something, we just have nice 3 lines and it's just nice, easy to see because this will unwrap it automatically. So the main function uses the await keyword in front of read file async to let other Dart codes such as event handlers use the CPU while native code like file IO executes. Using await also has the effect of converting the future string returned by read file async into a string. As a result, the contents variable has the implicit type string. So this is easy for me because I'm used to that. The await keyword works only in functions that have async before the function body. Exactly. As the following figure shows, the Dart code pauses while read as string executes non-Dart code in either in either the Dart runtime or the operating system. Once read as string returns a value, Dart code execution resumes. Yep. So await read as string, it just does this, and when we return, we just line up another future. Streams. Dart also supports asynchronous code in the form of streams. Oh, another thing to keep in mind is that, when this returns, it doesn't notify anywhere, only we'll be checking for it, checking for features if they're resolved whenever one task finishes or executes something else that's async, right? So it'll be gonna be one by one only. So Dart also supports asynchronous code in the form of streams. Streams provide values in the future and repeatedly over time. A promise to provide a series of integer values over time has the type stream of int. In the following example, the stream created with stream periodic repeatedly emits a new integer value every second. So we have stream, right, of integers. So stream periodic, and we give it a duration. And then what to execute on the duration, I guess, right? So await for and yield. So that's what probably relates to that. Await for is a type of for loop that executes each subsequent iteration of the loop as new values are provided. In other words, it's supposed to loop over streams. In this example, a new value will be emitted from the function, SumStream, as new values are emitted from the stream that's provided as an argument. The yield keyword is used rather than return in functions that return streams of values. So we can basically do SumStream, right? So we're gonna take in a stream, it's gonna be asynchronous so that we can use await, right? So we're gonna basically await for values here, and every time we get a new value, the return value will be basically increasing. So we're transferring one stream into another. Okay, that makes sense. And I can already see that we actually don't need to yield every time. We can kind of yield only when we have to. So this will be again asynchronous. So you could, in theory, convert a stream of 300 values into 30 values, right? And all synchronously, so you wouldn't have blocking stuff by waiting. So this is exciting. If you'd like to learn more about using async await streams and features, check out the asynchronous programming tutorial. And then we have straight out isolates. So we'll see how much we want to read about that, because our time is limited now. We have half an hour left. Dart supports concurrency via isolates. In addition to asynchronous APIs, most modern devices have multi-core CPUs. To take advantage of multiple cores, developers sometimes use shared memory threads running concurrently. However, shared state concurrency is error-prone and can lead to complicated code. Exactly. Instead of threads, all Dart code runs inside isolates. Using isolates, your Dart code can perform multiple independent tasks at once using additional processor cores if they're available. Isolates are like threads or processes, but each isolate has its own memory and a single thread running an event loop. Okay, so you can still use asynchronous code within isolates. Each isolate has its own global fields, ensuring that none of the state in an isolate is accessible from any other isolate. Isolates can only communicate to each other via message passing. Okay, so we have channels. Yep, I'm getting Go vibes. No shared state, just messages. No shared state between isolates means concurrency complexities like mutexes or locks and data races won't occur in Dart. That said, isolates don't prevent race conditions altogether. For more information, just read about the actor model. Okay? Only the Dart native platform implements isolates. To learn about Dart web platform, see the concurrency on the web sections. I guess it will be different because you need to deal with web workers. Okay, so the main isolate. For most cases, you don't need to think about isolates at all. Dart programs run in the main isolate by default. It's a thread where a program starts to run and execute as shown in the following figure. Okay, so we have event loop, main isolate, right? Repaint, painting, right? Does it, whatever. So event loop is kind of displayed as a separate, but probably not really. And that's it, right? No big deal. Even single isolate program can execute smoothly before continuing to the next line of code. These apps use a single wait to wait for asynchronous operations to complete. A well-behaved app starts quickly getting to the event loop as soon as possible. The app then responds to each queued event promptly, using asynchronous operations as necessary. So the isolate lifecycle. As the following figure shows, every isolate starts by running some Dart code, such as the main function. This Dart code might register some event listeners to respond to user input or file IO, for example. Then the isolate's initial function returns, the isolate stays around if it needs to handle events. After handling the events, the isolate exits. Okay, so we have event loop. Are there events? Let's spawn an isolate, run some code, optionally respond to events, and exit. Okay. So this is when we explicitly spawn it. I don't think the main isolate just comes in and out, right? So event handling. In a client app, the main isolate event might contain repaint requests and notifications of tap and other UI elements events. For example, the following figure shows the repaint followed by tap event followed by it's the same thing. Event handling happens on the main isolate after main exits. Oh. So when the main function just exits, the event handling just begins. What? In the following figure, after main exits, the main isolate handles the first repaint event. After that, the main isolate handles the tap event, followed by a repaint event. If a synchronous operation takes too much processing time, the app can become unresponsive. In the following figure, the tap handling code takes too long, so subsequent events are handled too late. The tap might appear to freeze, and an animation it performs might be jerky. All right, so repaint and process tab just does it here. Frame gap, expected time between repaints, actual time between repaints, right? So this took too long, therefore next repaint will take place after that, and it's like, ooh, we got laggy app. In client apps, the result of too lengthy synchronous operation is often janky, as in not smooth UI animation. Worse, the UI might become completely unresponsive. So you have background workers, right? If your app's UI becomes unresponsive due to time-consuming computation, like parsing a large JSON file, for example, consider offloading that computation to a worker isolate, often called a background worker. A common case shown in the following figure is spawning a simple worker isolate that performs a computation and then exits. The worker isolate returns its result in a message when it exits, right? So whenever we use the process tab, it's gonna be excessive callback. So let's just spawn isolate. We return immediately here. When it exits, it's gonna return results as a future, whatever result future, and it's gonna insert it into the event loop. A worker isolate can perform I/O, reading and writing files, for example, set timers and more. It has its own memory and doesn't share any state with the main isolate. The worker isolate can block without affecting other isolates because it's on a separate thread, right? And I believe it can still have its own async await. So using isolates, there are two ways to work with isolates in Dart, depending on the use case. Use isolate run to perform a single computation on a separate thread. Okay, that's simple, right? Just run it and return, and that's it. It, I guess, returns a future, right? Yep, it returns a future. So then we have use isolate spawn to create an isolate that will handle multiple messages over time, or a background worker. For more information on working with long-lived isolates, read the isolates page. Does it return a future? It also returns a future of isolate. So I guess you could check it from that time or wait until the whole thing finishes somewhere else. Okay. In most cases, isolate run is the recommended API to run processes in the background. So isolate run. The static isolate run method requires one argument, a callback that will be run on the newly spawned isolate. So we have slow Fibonacci, which just does that. It's not even async, it's just computation. Compute without blocking current isolate. So it's an async, right? We say result is await this and isolate run. We just run it there, bam. And because it's async, it's just stop doing stuff, whatever it was doing. And whenever it returns, then we're gonna continue and print this part. All right. Performance and isolate groups. When an isolate calls isolate spawn, the two isolates have the same executable code and are in the same isolate group. Isolate groups enable performance optimizations such as sharing code. Okay, a new isolate immediately runs the code owned by the isolate group. Also, isolate exit works only when the isolates are in the same isolate group. Okay, so we're going some special cases, spawn, URI, blah, blah, limitations. They aren't threats. If you're coming to Dart from language with multi-threading, it'd be reasonable to expect isolates to behave like threads, but that isn't the case. Each isolate has its own state, ensuring that none of the state is in an isolate is accessible from any other isolate. Therefore, isolates are limited by their access to their own memory. For example, if you have an application with global mutable variable, that variable will be separate variable in your spawn isolate. If you mutate that variable in a spawn isolate, it will remain untouched in the main isolate. This is how isolates are meant to function and is important to keep in mind when you're considering using isolates. But they might run on a separate thread, right? Okay, so it's like more restrictive separate threads. Message types. Messages sent via send port can be almost any type of Dart object, but there are a few exceptions. Objects will make the resources, the sockets, receive ports, dynamic library. Okay, so you can't send DLLs, DL bindings. Finalizable, finalizer, native finalizer. Okay, it's like distractors probably and stuff, or pointers. All right. I mean, pointers would make sense because the other isolate is like separate and won't have access to stuff. All right. And instances of classes that are marked with the pragma isolate unsendable. There you go. So apart from these exceptions, any object can be sent. Check out the send port send documentation for more information, and note that the isolate spawn and isolate exit abstract over send port objects, so they're subject to some limitations. Okay. And then we have synchronous blocking communication between isolates. Let's skip that because we don't really care about isolates that much. This will be something we can catch up on if we're gonna do some more interesting stuff. I'm already getting some ideas about this. Concurrency on the web. So this is how to tackle it on the web. I don't care about the web right now. and additional resources plenty. So lastly, last short article is just more on asynchronous programming. I don't expect we're going to learn anything crazy here. It will be just, a little repeat. But let's finish that off so that we're done and ready to start making a web server tomorrow. Okay, so Dart libraries are full of functions that return future or stream objects. These functions are asynchronous. They return after setting up a possibly time-consuming operation, such as I/O, without waiting for that operation to complete. The async and await keywords support asynchronous programming, letting you write asynchronous code that it looks similar to synchronous code. Okay, so handling features. When you need the result of a completed feature, you have two options. You use async and await as described here and in the asynchronous programming tutorial, or use the future API as described in the Dart async documentation, which is core libraries, Dart async, a little bit more. All right, no big deal. Code that uses async and await is asynchronous, but it looks like synchronous code. For example, here's some code that uses await to wait for the results of asynchronous function. Await lookup version. To use await code must be in an async function, a function marked with as async. There we go. Again, after the name and stuff. And therefore we can use it. The await. Note, although an async function might perform time-consuming operations, it doesn't wait for those operations. Instead, the async function executes only until it encounters its first await expression. Then it returns a future object, resuming execution only after the await expression completes. Okay? So use try, catch, and finally to handle errors and cleanup in code that uses await. Yep. Exactly like C#, exactly like JavaScript. Yep, so try to do something, and if this failed, we can catch the error. You can use await multiple times in an async function. For example, the following code waits 3 times for the results of function. Wait, wait, wait. But, they don't block between each other. In await expression, the value of expression is usually a future. If it isn't, then the value is automatically wrapped in a future. Okay? So that might actually slow your code down, because even if the future returns immediately, you still put it on the event loop. Therefore, something might be executed before it actually goes, because on event loop, it just is at the end of the queue and that's it. This future object indicates a promise to return an object. The value of await expression is that returned object. The await expression makes execution pause until that object is available. If you get a compile time error when using await, make sure await is in an async function. For example, to use await in your app's main function, the body main must be marked async. Yes, I guess there are lots of people just not getting that, and they need to repeat it like 3 times. The preceding example uses an async function, check version, without waiting for a result. A practice that can cause problems if the code assumes that the function has finished executing. To avoid this problem, use the unawaited features linter rule. Okay. For an interactive introduction into using features, async and await, see the asynchronous programming tutorial. And that's beyond core libraries. We have asynchronous tutorial features and handling. Okay, so there's some more, but no big deal. We don't need that, I think, yet. If we'll find an error, if we encounter any errors tomorrow, which I doubt so, we can always look it up, right? All right. Declaring async functions. An async function is a function whose body is marked with async modifier. Adding the async keyword to a function makes it return a future. For example, consider this synchronous function which returns a string. Bam. If you change it to be async function, for example, because a future implementation will be time consuming, the return value is future. I guess it will. I just want to see if it actually forces me to do that. So let's say I define it somewhere here. Bam, right? So I'm going to slap on an async. Okay, it actually forces me to put a future here. Okay. All right. If you change it to be async function, for example, because the future, yeah, we went through that. Note that the function's body doesn't need to use the future API. Dart creates a future object if necessary. If your function doesn't return useful value, make it return type future void. Okay. For an interactive introduction to using futures, tutorial again, geez, 30 times. Handling streams. When you need to get values from a stream, you have two options. Async and asynchronous for loop, the await for, okay. Or use the stream API as described. So I guess, next, like await next, or something of this sort. So basically, if you're going to get 30,000 objects from a stream, you're really awaiting 30,000 futures. One by one. Before using await for, be sure that it makes the code clearer and that you really do want to wait until if you and that you really do want to wait for all of the stream results, right? For example, you usually should not use await for UI event listeners because UI frameworks send endless streams of events, right? And asynchronous form, an asynchronous for loop has the following form, right? Await for, and you have bar type, right? Identifier, and the expression. So the expression here will be something that returns a stream, and this will be each entry of the stream. So the value of expression must have type stream. And CPN, when did you get back? Long stream today? Kind of, literally finishing. Try catch is everywhere, it seems. Yeah, try catch is the standard way. It works, it's not the best, not the worst. I know Zig has its own take on it, which apparently is pretty good. Just don't know how it would work in a high level system. Okay, so execution proceeds as follows. Wait until the stream emits a value. Execute the body of the loop with the variable set to that emitted value. And then repeat 1, as in wait until the next value. And 2 until the stream is closed. Just keep going back and forth. To stop listening to the stream, you can use break or return statement, which breaks out of the loop and unsubscribes from the stream, right? So you're like done. I guess you could still hold the stream and resubscribe to it, I presume. If you get a compile time error when implementing an asynchronous, yeah, it's the same thing. Sure, make sure it's okay. That's it. Yeah, Zig just returns error as a union with a value. That's the thing Dart doesn't have. Dart doesn't have unions, and that sucks because unions are beautiful. And that's, again, C# is getting unions soon, probably in a year from now, but very excited. Very, 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 very excited. Okay, so that's it for all the documentation from the stream of pure reading documentation. I believe it was worthwhile to actually get through everything about those classes because they're kind of wacky, but you need to know about that in here, I believe. So yep, that's that. Concurrency seems very straightforward, very JavaScript like, no big deal, feel like home, and no safety. We will probably have a few things to check for tomorrow, and that's it. And for keywords, there's not that many. Abstract, as, assert, async, case, break, base, await, catch, class, const, continue, do, deferred. We didn't see the deferred. Oh, that was with lazy loading, right? Where's the deferred? The lazy load library. Oh, deferred as hello. Okay, so that's it. We can't do like deferred execution. Too bad, because that'll be fun. And Claude probably here. Wow, it's still going. Holy moly. How is it doing that? All right. Covariant default for all that stuff. Dynamic else, enum export, external extension. I'm just looking for something I'm not familiar with. I think so far so good. Yep, rethrow. All right. All right, everything seems familiar, so that's great. I think we have a good grasp. If we understand everything like that, that's great. And CPN is asking, looking forward to seeing you make a web server. Yes, it's gonna be very basic because we don't have like big frameworks, but I think it'll be good enough. I'm curious how connecting to SerialDB will look like from here, but so far it will be very fine. Does C# has the first statement? I don't think so. That's actually a good question that I kind of would need to verify, because sometimes it's hard to keep up with how quickly C# evolves. Does C? I mean, you have like using statement that you can defer some things, like and clean up afterwards, but not like exact equivalent. Does C# have an equivalent, whatever, of defer like Go has, right? Google it. I want explanation. Google won't just tell me, here I'm gonna get like, hey, we kind of have this and that. Oh, exactly. I will said, we don't have the equivalent like direct. We have using statement, which is you have kind of specific specific types of objects or whatever that basically require cleanup, that you need to close it afterwards or something, right? You can explicitly declare something that needs to happen like that. It's called disposable. iDisposable. It just needs to implement that interface. And therefore, you do using as the reader, right? With this. And because of the syntax, it will automatically just dispose of it. In this case, it will actually close the file reader, right? You won't just leave it open by accident. Without that, the old syntax was that you needed to call using and do it here, and it closes automatically here. So this is kind of equivalent of defer. And finally, in try catch, that's the joke. Custom defer implementation. What the hell? I guess you could try that. Yeah, so not really. Not really. Too bad, because the first one. All right. So that's it. We're starting next stream in what? 9 minus 2 is 7. In 7.5 hours, we're gonna start a new stream. So I'm gonna go and get some sleep and heal my throat, because talking so much is tough. I don't know how long tomorrow's stream will be. The main goal will be just to create server, have some basics, test some responses, have some basic structure with maybe some config loaded from, I don't know, environment variables, and to be able to connect to an instance of SerialDB and just test to see if we can get data. If we'll have that, we'll be able to start streams that are combined at the same time Dart and React, and we're gonna finish the app. And that's pretty much it. So thank you for watching, and good night, everyone. Good night, CPN, and I will sleep well. I hope you can sleep well too, unless it's like morning for you. All right. See ya.